Let's get this mic set up right. Am I online? Doesn't look like I am. I am online. I just had to refresh the stream manager page. It's weird. Well, hello. So you're watching live, or more likely watching the VOD. I'm working on this programmable parser, and today I thought might be a great time to do the meta challenge, which is have the parser parse itself. So, for example, what you're just looking at there is described here. This is the custom language that the parser uses to parse things. Why not make a description of how the parser can parse its own language? So that's what I'm going to work on today. First of all, I need to have a new file. Let's call it fmt.toml. Formats is going to be fmt.fmt. Root and scripts. No scripts. Okay, so then I need fmt.fmt. Hey, develop it. Mostly. Yeah, I had I still think I still have it, a migraine that's lasting a long time, like weeks, and it's coming and going. It's like a headache at the corner. Like if I move suddenly, or if I like look a certain direction, it's like, oh yeah, it's still there. All right. What I'm trying to get to is my own parser's format representation for what its own grammar is. So this being the top level grammar. Actually, I guess I should just model it correctly. This should be called formats. And then this is, I don't misspell it. What's the key combination to go to the next tab? Control page. Oh, that's the next terminal. Tab. Editor. Next editor. Hey there, Raphael. Control page down. That's a weird one. Okay. Can I memorize that? Not really. Yeah, let's call it formats. Control page down. There we go. Okay. So formats is basically a list of format, one after another. And in the grammar for the language, there are these special rules that you start with an empty list, and then off of that, you build the next one. This rule is sort of a special one for decorating syntax errors, so I'm not going to really care about that one. Really, it's really this rule that I need to convert. So the idea that we're forming a chain by having just we just keep parsing a format, and that's what I want to represent here. So I also wanted to steal a little bit from the JSON format. Oh, and I wanted UTF-8 characters, so why don't I just grab that right now? What's a programmable parser? I'm glad you asked. So this is what it is, what it looks like. You throw a file into the tool, and on the left it shows sort of a hex dump of the overall file, and on the right it shows what is the output of parsing that file. So this is an animated GIF, right? So these are the individual frames of the animated GIF. So it's the Pog slide one, right? You might have seen that one before. And so, for example, here's the header. There's the signature that marks that it's a GIF. Here's the version number and how it's encoded. Here's the screen descriptor that has the width and height of the image, basically. And then there's the color table, so individual colors in the color table, red, green, and blue values there. So it's programmable because you, in addition to the actual Pog slide GIF here, you give it this description that says, here's how you parse a GIF. So if you see here, this is the overall GIF file, and there's the header, screen, data blocks, and trailers. So that should mirror the structure at the very top level here: header, logic, screen, data, trailer, right? And data has 21 blocks in it because that particular file has that. The parser doesn't know that in advance, so we have to do a loop where we're parsing data blocks until we see a special marker byte 3b, which is at the very bottom of the file. That 3b here is the trailer. So this language looks kind of like C, but instead of executing functions in a programming language, so to speak, it's more like how to parse a file given as a recipe, and it's compositional. So the overall recipe for the whole file leverages these sub pieces or components, right? So when it gets to this line header, it's like, how do I parse the header? Oh, the instructions are here. And there are some certain built-in types like S for string, UI for unsigned integer, but everything else is sort of like built up as building blocks. So like going in order, it's like, okay, this is an instruction that is little endian order, so low order bits first in a byte. Then parse the header. Oh, header, parse a string. This means it's 24 bits. So that corresponds to this signature. 24 bits is 3 bytes. And then we do a signature check, otherwise parse the version. The version is another 24 bits, right? So that's this encoding. So 89A, we say, well, if it's 89A, it's the 1989 version of GIF. Yeah. So I made formats for GIF and for JSON. So JSON, a document is a value, and a value, you have to look ahead one character, and if it's a curly brace, it's an object. If it's a double quote, it's a string, etc. And so, for example, one cool thing is, let's say the document value is an object. Well, an object is an opening brace and then one or more name value pairs with a commas between. And a name value pair is a name and a value. And see, that's the same value as the top level document. So it's naturally nesting and recursive in nature. So I also dabbled in making a format for MVE. This is the interplay video format used in Fallout and Baldur's Gate, some older interplay games. And I haven't finished it yet, but another Twitch streamer named Quantum Apprentice is working on handcrafting a parser for this. And I thought, hey, let's see if my parser, how hard would it be to describe the format with my parser? And so far so good, but I haven't gotten into these other opcodes. And the most interesting one, I think, is the video. Where is it? Video something. Video data. So that one's like really, really incredibly complicated. So just like anyone writing their own compiler or interpreter, the meta challenge is, can the parser parse its own language? That's what I'm trying to do with this fmt.fmt. So we're going to describe in my parser's parsing language or format language how to parse itself based off of its own grammar. It's JSON because it's a data container. I just picked JSON. So this will parse JSON files. And this will parse MVE files. And this will parse GIF files. So the idea is that I could write a .fmt for any conceivable format, like JPEG, MP4, MP3, and not just files, but any kind of data. So it could be packets captured from a network interface. So like TCP/IP packets, we might take a look at parsing that at some point. But then, yeah, meta is, can it parse itself? So that's what I'm working on today. So, among other things, what I am doing, besides the programmable nature of the parser, it also has this user interface. So I made this xdump thing, this data tree, and then the last month, this is the newest addition, is that we have an image viewer, so that if any part of the parsing output is viewable as an image, we can throw it down here in this panel. So that's why now when you click on the graphic rendering blocks, those produce images, so we can see them when we click on them. It is a huge work. I've been working on this for years. And thank you. I find it just I like the challenge, but also I think this tool could be really useful for me in the future if I ever need to like investigate a new format, or maybe repair a broken file, or just as a tool in general when like working with encoded data. So like a friend of mine is working on a program that like he's reverse engineering the Digimon formats, like the files that are included in the Digimon game, and it has all the assets of the game, and it's not really well documented, so he's reverse engineering it. So my tool could be helpful for reverse engineering, because you can just make guesses on how to parse things, and you can see, well, like, what does it turn out to be, and does it match, and just iterate that way. So I was talking to him about maybe at some point pulling in all that he knows so far about his Digimon stuff, and see if I can put it in my format language. This is inspired by MPEG. So the ISO spec for MPEGs, like MPEG 4, they describe all of the bitstream formats, like for video and audio and containers, in this kind of a format where it looks kind of like a programming language like C, but there are lines for saying, like, when you get to here, parse the next certain number of bits as a certain type, and interpret it a certain way, like with a name or a variable or something like that. So that's where I got my inspiration from. All right, so yeah, I was gonna take this concept of optional white space. I think this is incredibly important, because my formatting language, kind of like JSON, allows you to put white space almost everywhere, and we want to be able to ignore it. And so every place that we might have optional white space, we're going to want to skip it. So that includes the outermost construct, right? So when we have a format, which is an identifier, some arguments, a left brace, some statements, and a right brace, between any of those, we can have white space. Hey there, cat peasant. No preserved cat peasant. What? Cat peasant. Do you have no sense of self-preservation? Let's see. Actually, do I need it at the top level, or can I just say loop? Actually, not loop, but while remaining is greater than 0. That's what I did in the MVE, right? Yeah, while remaining is greater than 0. Format. And then we can just say a format can have white space around the various fields. So field would be like an identifier called name, and then optional arguments. So I'm going to try to mirror the grammar as close as possible. So why don't I just pull this in and just translate it? So this one would be basically the type is first, and then the thing. Actually, you know what I'm going to do? I'm going to build in optional white space in the leaf nodes. I think that makes the most sense. So we'll see this again, like in ID. Then we'll put, have it skip the white space there. How about that? Oh, I forget what it's called, but yeah, the font that I use. I think it's in my font command. No, I don't have it in there. Trying to remember what the name of that is. But it's where there are two symbols there, but when you put them together, the font draws in a different way. Memory is terrible. Ligatures, that's what it's called. So, Vera code ligatures. Yeah, they put it right in the top page. Programming ligatures. So it's a feature of the font that I use that it has ligatures, which are those things that we're talking about, where if you put two certain characters next to each other, it draws it differently. That's a ligature. So they're programming ligatures. So symbols that you'd see in programming. And so yeah, their whole description is like the human brain sees it as two tokens, but it's really one to the humans. And like here are the things that are supported. You can turn it on or off. But yeah, that's one thing I think is kind of cool. That's why I use that. Also, I think it's easier on my eyes. All right, so if I'm putting the optional white space at the lowest level, and one here, I'm putting one here because if I don't put optional white space there, then the remaining might only be white space, and then we won't match a format. So that just eats any terminating white space. So we have so no white space in the intermediate levels. So we have arguments, and then we have brace, L brace, and then yeah, just translating from Lollipop syntax to my syntax. Well, I'm using VS Code. Do I have an IDE command? VS Code? I do not. Why do I not have commands for these things? Yeah, I use VS Code. And in VS Code settings, you can set your editor's font family. So I just have it set to Fira code if we have it, and then it defaults to Consolas or Courier New or Monospace. We can't find those fonts. So because the VS Code allows you to pick a font, and if the font has programming ligatures, you'll just get these automatically. Actually, there was another thing there, right? Yeah, you can turn them on and off in VS Code. So if I turn this to false and then go back, you can see that the ligatures are gone. We're back to old school, no ligatures. But I can turn them back on. So your editor, if it's different, may vary on how you do that. So you might have to pull in the font and figure out your editor's own way of turning on or off the ligatures, if they're not on automatically. And I'm pretty sure that if you go to the Sphere Code site, they probably have instructions. Yeah, see, they have a compatibility list. So let's say you're using Vim, which probably everyone but me uses at this point. So or NeoVim, right? So if you go and find NeoVim, I guess it's in there, and it's listed as it works. So I suppose it works really well because there's no instructions link, but I suppose like if there is an instructions link here, it means there are some things you have to do. So yeah, there's like all sorts of good information if you just check out that GitHub. All right, so I don't want to try to describe everything. I kind of want to just describe it at a super high level and see if it works. And before I get too far, I want to actually load it here. So let's close the data, close the config. That's a little artifact that doesn't go away when it should, but if I close this and run it again, it'll go away. Yeah, right. So then open config. Oh, I forgot where we were. Oh well. Well, we're on home, remove projects, integrator examples, format toml. Okay. And then open data. We're going to have it open itself because it's totally meta, right? So projects, DataDisintegrator, examples, fmt.fmt. It's going to open itself. So unknown format op arguments. So we're going to run into this a lot where it doesn't know how to parse something. Name is empty because I wasn't done with that one. But so here's the meta illustration: is you'll see that we're parsing the file that describes how to parse itself. So this formats matches this, right? So that's literally the same file in that hex editor as what we're working on. And the goal is that when I'm done, it should be able to parse itself. Okay. So I guess I do. Yeah, I did have ID here. I guess we'll skip to ID. So ID is whenever something's in double quotes here, that means it came from the lexer. So I need to go to my logos or output from the logos here and go to identifier and try to translate the regular expression into my language. Parseception, that's right. And how are you doing, Kashanks? Where's identifier? Why am I not seeing it? Because I'm blind. Okay, here's identifier. So it's an alpha followed by 0 or more alphanumerics. So alphanumeric. And then I guess it's while. I guess it's a loop, right? And then we're going to be building. We're going to be building something that we return, right? So first, and then name equals first, return name. And the problem is we need to know when to stop. So we stop when it doesn't match alphanum anymore. What if I just make a helper that does check if alphanum? So look ahead, check alphanum, if check, else break. Actually, this pattern I already kind of have as alt, right? So then it would be alt, not look ahead, just call it alphanum, next. And then if there is a next one, we do name plus equal next. Okay, let's see if that, well, I need to have an alpha and an alphanum, right? So that's literally like a character as uh, UTF-8 char, right? Yes, one of those. And then, can I just copy from here? Because I did the similar thing here, right? Where I did a check. Digit. Yeah, this thing, right? Whoop. I did not mean to press that, whatever that was. So here. So oh, and I think I learned later that I could do a character check with this. And where was that? Yeah, I could actually put a character as a string in there. So if I did the char trick, so if I do char next, char C, A, in double quotes, through Z. Oh, but how do can I do subtraction with this? I don't think I can. So I think I'm gonna have to have that ASCII table ready here. It's 61 hex. And then we have else if for capital A through capital Z. And then that is 41. And then the numerics. And then do I also allow underscore? I do. Look, there's an underscore right there. Can't forget underscore. Actually, why am I subtracting? That's if I wanted to turn it into an offset. So I actually don't want that at all. And that means I should probably collapse these all into one huge if, right? Underscore. Yeah, so this is alpha. I just did alpha num, didn't I? All right, well, I'm gonna end up copying that anyway, so we'll do alpha. I'll just do this right now. I'll say pretend we were doing alpha num all along, and then yeah, I think it makes sense to collapse these. Or my cat wants attention. There's no one here to give her attention. Just gonna meow in the background. We're away from you guys so you can't hear. Okay. I think that works. I'm gonna take that, I'm gonna copy it here and just remove the numeric part. And say alpha. Okay, now if I did that right, this should parse at least the name. Yep. Formats, yay! Okay. It gave the value 764, which is wrong. So I must not oh, I'm supposed to return char C. I'm doing char all the time. Why don't I just say call this code and then we'll do C equals char code. And then all the char C's become just C's. And the same thing down here. Oh, hello, kitty. Look, we have work a kitty. Meow. And out the window. Goes here. All these char C's become C. Okay, if I save that, reload this. Hey, look, the name is formats. She likes to come over here and like stare out the window because I don't let her out because I don't want her to get fleas or get eaten by coyotes. Yeah, she's a jerk though. Don't let her fool you. If you pet her too much, she'll reach around and bite you. I still love her though, even though she's a jerk. So yeah, so we can see we can parse the name, and if we care to, we can see the first character followed by the next. And if we really want to, we can dig into that and we can see the code behind the that first character. We can see it's a UTF-8 character. We can actually see the individual encodings. But if we only care about that it's a name, we see that. It got 10 times more interesting to develop it. That's why I have this. This other camera is courtesy of YGT Ski Dog, who was back during COVID. You could not get these cameras, and he had an extra one, and he was nice enough to give me his extra one. And now the cat's gone, so the stream is going to get 10 times less interesting, unfortunately. Sorry. But yeah, I got that second camera just for when the cat goes and gets nearby. All right. The current error is what? Oh, I cleared it. So let's just hit the file to see the errors again. Unknown format op args. That's next, I guess. Your cat and chinchillas are currently sleeping, so they are also quiet. Well, we'll try to see if we can get the cat back. Anyway, op arguments, it doesn't know how to parse that yet. So I think I'm going to try to have the higher level things up top and the lower level things down the bottom. So the lowest level is the optional white space, right? And do you see, it's kind of subtle, but do you see the difference when I have the parentheses or not? That's actually a bug in the plugin I made for VS Code that parses my own format. I forgot that I could have an empty parameter list for a format. If I put something there, see the loop goes back to being purple, but if I take that out, it goes back to being yellow, and if I remove it completely, it goes to the correct color. I need to fix that bug. But not right now. I have too many things to do. I'm doing op args next, right? And I was saying that I want to put it above ID because ID is lower level than op args. So op args is going to be like either nothing or a parentheses. So I think what we'll do is we'll skip the white space and then we'll look ahead and see if the next character is a parentheses. So oh, one thing I just thought of. I wonder if I can collapse these two levels here. So if UTF-8 character returned an actual string instead of a code point, maybe that would be more useful. Or no, wait, I might want to see the code point. So I'm going to keep that. So never mind. But I could wrap that, right? I could wrap it with just... Actually, I'm just going to wrap it the way that the grammar does. There's an L_paren token. So we'll do the same thing. Actually, that'll make it more closer to my grammar. So it would be look ahead. Well, first I need to skip the white space. Do I look ahead and then Yeah, it's ut. Well, what am I doing? Can I just do the same thing I did here? Or what if I just parse it twice? Yeah, let's parse it twice. L paren. Um, do I need to give it? I think if without a name, it gets its own name, right? So let's just say look ahead. If I don't need to do this, do I? I can just do the same alt trick. So I have this alt syntax and I keep forgetting I can do that. Yeah, it would just be alt. And we don't need to look ahead anymore. It's just L paren. And then if it's an L paren, then we get the rest of it. Else, actually there's no else. That makes it completely optional. The only problem that I have with this is that if I have any errors in here, they get eaten, and I kind of don't want to have errors that are eaten. So then I think I'd rather actually use the old style look ahead. So it can't be an L print. It's got to be we have to look one character ahead. Yeah. Then it's L print. And because arguments is kind of complicated right now, let's have it skip it by just eating every character until we get a right paren. How is alt defined in the grammar? I'll show you. So it is right here. Alt, left brace, some statements, and then a right brace. And the statements have to be parse statements. So the idea is that if you're in where's a good example of this? Maybe in the unit tests? Yeah, okay. So if you're parsing some format called foo, and foo can start with either a bar or a baz, you would say these are some alternatives. The next thing might be a bar. If it is, name it X. If it's not a bar, try baz. If it's a baz, name it Y. So and the idea is that if we have any trouble parsing it as a bar, we rewind and we forget that we had any errors. So it eats all the errors. So that's one side effect that's I have to keep in mind is that if any error happens parsing bar or baz, we never see it because alt is saying, hey, we don't know what's next, so try a bar. If it's an error, just try again with baz. So it'll inherently ignore all errors, and it'll basically walk down. And the first one that parses successfully, it keeps that one. It skips the rest. So if it is a bar, it does not parse baz. If it fails to parse a bar, it'll try baz, and if baz does succeed, we'll get a Y back. But if baz also fails, we get nothing for the entire alt. In that case, we go into the else statements. So the idea there is that if you needed it to be one of these two, and if it's neither, you would throw an error from else. But you might also say, hey, it could be one or the other or neither, right? In that case, you don't have an else. So that's it's syntactic sugar around the looking ahead to see if something matches, and if so, parse it like that. Otherwise, try something else in an if-else if. So kind of like this, where we're looking ahead one character, and if it is a parentheses, we parse it again as a parentheses. This time, we're going to expect it to be a parentheses, right? But because of the side effect that we ignore errors, if I if I put everything inside a huge alt, we would never see any errors if we had any. So that's the downside. So it can be used for exception handling, but mostly the idea was that alt for alternatives. Like alternatively, the next thing might be one thing or another thing, and if it's neither, then execute an else block. It's just that the side effect is like in order to try it as one way, and if it's not, to go back and try again. That means we have to catch the exceptions and handle them by rewinding the bitstream and trying again with a different format. So the exception handling is different inside an alt block. Instead of an error throwing all the way back up to the parent, an error actually tells the alt, go to the next alternative and try that. So anyway, I think I've described it 3 or 4 different ways there, and my hope is that one of those ways worked. So anyway, we're gonna want to eat the white space for the right paren, right? Actually, maybe we don't need to do that. Let me think about this. I think, well, right now this is going to be to do parse well, span really is just a decorator around statements, right? So it's really just statements. Right now, though, we're just going to say loop. Can I rename it? I don't think I can. I'm gonna call it next. If next break else ignore it. Okay, so I need very similar to alpha and alpha num. We need lparen, right paren. So it would be the code, and it would be if it is not equal to left parentheses. Actually, I could make this a parameterized thing, right? I could, but I'm not going to, because the grammar calls out it's op arg is actually what I'm supposed to be looking at. Lparen as a special token rather than it being a parameterized thing. So yeah, I'm gonna do this on purpose. Yeah. In my mind, I'm like going back and forth. Do I want to do it that way? Because the alternative would be that I have here's the alternative. We would have some kind of token expected, and then we would just say that is it expected, and then it would be expected is expected, right? If it's an error. So that's a parameterized one. So I can in up here if I wanted to. I would say like instead of lparen, it would be token left parentheses, right? And I could name it lparen if I wanted to, but I'd rather just make it explicit like that. Let's see what I get. Okay, I have a syntax error line 27 because there's no semicolon there. All right, so we got name is formats, um, unknown format lbrace. Okay, so it skipped the optional arguments is skipped. It ate the white space character for it. Right, that's exactly what I wanted. So we need to have lbrace. That's just like lparen. So let's just copy these, and we'll just replace paren with brace, and then that's that character, and that's that character. Then should match the brace, and then we're on to statements. Cool. So I don't need to have it say spanned. We'll just have it say statements. That way I can just reduce that to that. And now we have to define what statements is. And here's where we get into the hard part. I wonder if I just want to skip it and basically go to the next end brace and temporarily handle interior braces. I think that's what I'm going to do. So we're going to have a temporary thing to just eat all the statements. So it's going to be get rid of some initial white space. Actually, I don't need to do that, right? We just need to eat it character by character. And we'll have a counter. So level. Started at 1, and basically every time we see an opening brace, we'll add 1 to that. If we see a closing brace, we'll subtract 1 from that. And when it reaches 0, we'll exit. But we can't eat the last brace. So that means I'm gonna have to do a look ahead. So yeah. So loop. Okay, we don't need the optional white space thing right now. Look ahead. If C equals opening brace, else if closing brace, else. Guess I don't care about the else. If we get to here, we want to actually consume it. So I'll just ignore it. So this will be level plus equal 1. This will be minus equal 1 with a check if level equals 0, break. So that should eat all the statements now. Minus unexpected in line 43. Oh, I don't have a minus equal. I have to do plus equal minus 1. That, oh, and to make that work, I need to explicitly make that signed. Think? Okay, how far did we get? Oh, we did it. All the way to the end. Okay, it broke here. We had a problem with the op arguments, I think. Oh wait, no, it's just that the arguments needs to eat any following white space. So that would be here. Or should it be up here maybe? Let's just leave it there. All right, cool. So the entire file is now parsed. Just we don't descend very far. We're skipping the statements. Cool. All right, so I'm doing this from the top down instead of in order, basically. So now we've recognized all the formats. Okay, I think I want the value to actually be the name of the format before I go on. But yeah, so every element of the format array here is one format. And then we recognize the name, and I want to return that name. And the statements is basically all skipped right now. So, another thing I noticed is that this shouldn't collapse code like that. It should return the actual character. Yeah, this should be return C and all these primitives here. So now for L brace, it'll actually show the brace. That's just mostly for making it look good in the GUI. So the same thing for format, we should return the name so that now it should print the names here. Look at that. Isn't that cool? It just works. I don't really care about format per se. Anyway, which one? It was token had the optional arguments, right? Right. So right now we're ignoring the arguments. We're just recognizing the parentheses. Okay. Do I want to do statements next, or do I want to do arguments? Arguments might be easier to do because arguments is either an identifier. Oh, that's all. Actually, we can. This is easy. This is just a comma separated list of IDs. Hey there, Nightshade dude. We're doing the meta challenge, Nightshade dude. Can the parser parse itself? So this format describes the format language itself. So the goal is that this is self-describing. This should be able to parse itself over here, right? So there's formats while remaining all that. That's exactly this. It parsed itself. Because any good compiler or interpreter worth its beans or salt or whatever the expression is should be able to parse or interpret itself, right? Actually, before I go on, let's see if this token thing works. So that, now op args should, oh, no, it didn't work. 21. Oh, that's because the arguments go with the name, not the type. So that really shows up for token, right? Okay, so it still says code because token doesn't return the actual character. Okay, so the difference will be that it's called a token, not an arparen. Do I really care? It would be convenient to just have a reusable format called token and not have these special ones for L paren, right paren, left brace, right brace, all that stuff. Did I not do right brace? Right brace. I do have right braces before token. Ooh, there's a problem. Left brace 8 right brace. Oh, because it's inside of a string. Look at that. So it counted that as a level, even though it's not a level. Do I care about that? I sort of do. So it's in this level skipping code. It needs to know if it's inside of a string or not. So in string false. If in string else. And I'm not going to worry about escape sequences because that'd be too pedantic, and this is temporary code anyway. So if it's in a Let me handle it if it's not in a string, because I need to have an else if for double quote. Then in string equals true. And then I'm going to basically copy that to here. If it is, actually, that's the only thing we really do. If it's inside of a string, if we see the terminator, we say go back to false. So if I do that, then that should fix this so that we see our brace. Oh, we do. Look at that. Cool. Nothing is more permanent than temporary solution. I know. I should actually, I was thinking about this. I should actually name that temp skip until our brace. There. And we'll just ignore it. All right. So I was going to do op args next, right? Because that's real easy to do. This, and we can get rid of this temporary stuff, right? So we do want to look ahead one character, because if the look ahead is not a left parentheses, we don't want to parse anything. We just want to eat white space. So the that's correct, and I was leaning towards using token, right? So if we are using token there, I should use token here. Or lparen could just use token. I need to make this decision now before I have more of these points where I'm going to want to change my mind. I think I want to mirror the grammar. I really care about the grammar. The fact that it's a string here means that there's a lookup down here to a token. So I think, let me find where I was. Op arguments. There we go. That really is a type, right? That's the type, and that's the actual name for the type, because sometimes it's different. So I think I do want to not use token and have explicit lparen, rparen, at least. Now, those could leverage token internally. Maybe that's what I'll do. So to do that, it would be like lparen means token like that. That should still work, right? Only it broke down here. I don't understand. Oh. Did I have that wrong? Oh, yeah, that should be left print. I just got my left and my right screwed up. Okay, so that works. Does it look funny in the UI? It says left print is a token. That's because I have this rule in the UI that if a node has no value on its own, yeah, so if I turn that into return token, then it won't collapse them, right? It's if something doesn't have a value on its own, then it will collapse levels. So here it won't collapse a level. We're on token, right? So it's an L brace, so it looks the same as before, only if you open it up, you actually see. Oh, I'm looking at the wrong thing. Arguments. L paren is an L paren, but you will see this additional level of token. Do I really care? I don't care. And that actually makes it easier to write because I can just do this right here. Right? And then same thing here. The only thing is it used to say like RBRACE, and now it's going to print that. What if I have like expected and then name? Something like this, just to make it kind of look nicer. Oops. This is L brace. And then this would be name expected. That shouldn't break anything, right? Everything's still working. Okay, on to opt args. So actually that is L paren arguments right paren. So let's do that. L paren, right? And then arguments R paren. Return arguments. We should eat the white space there. Okay, and then arguments. There's where you need to have like, it might be empty, otherwise it's a comma separated list. So it's kind of like the formats? Or where was it? Where did I do this where it was op? Well, it was like op, right? Only with the loop. Yeah. Okay, I think I know what I know. I think I know how I want to do this. So I'm gonna do it this like the only it's instead of UTF-8 carets an ID. Or maybe as an alt? An alt else return? So this would be what no, I can't use an alt because I need to use the look ahead stuff. But if it fails to parse that, that would be bad. So it's gonna either expect an identifier or something else that parses correctly, that passes the lexer correctly, but isn't an identifier, right? Hmm. Well, an identifier always starts with an alphanumeric, right? Why don't I just look ahead and see if it's an alphanumeric? What if I do something like this? Is alpha next? And this does a look ahead. And this does a true false. Actually, I think I can just turn this into a return. So let's see if this works. So this would be if is alpha next, then this stuff. I don't want this stuff anywhere. It's like it's gonna be a loop. And we have to go until it's not next. Right? Oh, I changed it on the left. Huh. Okay. Let me think about this. We would get an argument. What am I calling it right now? Just ID. So argument. ID argument. Does ID eat white space? It doesn't. So we should probably do that at this point. And then do this again? Oh, it's either going to be a comma or not a comma, right? At this level, it doesn't look for parentheses. It's just looking to see if the next thing is a comma or not. So this should be something like is comma next. Else break. Well, if not is comma next break. Comma. And then loop back and get the next argument, right? Yes. I think that's right. So I need a comma, and I need is comma. A comma's easy because it's just like these other things. It's just a token. Comma looks like that. Oh, and I can have white space after the comma. But if I do, our ID will eat it. So this should just, I need to have is comma next. Actually, it's kind of like that, right? So why don't I steal this part? I should steal that and just use that like as a reusable thing. This like is token next. Token. And this is just return, right? So then I have this is token next comma. And then I can reuse it up here if is token next parentheses. See if I completely broke it or not. I broke it. Cannot set bounds without bitstream on an UTF-8. Okay, so unable to parse look ahead on line 98. I guess we skipped all the way to the end of the file for some reason. So it's on line 19. So it was in the middle of parsing arguments, and it didn't have a bound? What? It doesn't have a bit stream. Oh, I know why. When called in a function syntax, like this, this can't actually parse the bitstream. Yeah, okay, so I can't do it like that. Um, yeah. I'll be right back. Just a minute. Hello, I'm back. I know what to do now. Funny how you're using the restroom, like, helps you figure out what to do. I just need to break that out of the if. Say, well, let's rename it. Not is. Well, actually, no, I can do that. But I'm going to remove the word next from it. How do you select all? Shift Super L. Did that actually select all? It did not. Shift Super. Not sure if that selected all. I did. Okay. So is token. Just say is token. So then, yeah, I have to do with a look ahead. Although that seems a little bit unwieldy. The look ahead with is token. Next is lparen. I don't like it. I think I'm gonna get rid of this and just go back to what I had before, which is just this. Yeah. I like that. That's fine. Just do that. So it would be the same thing here. Get rid of this guy. All right. See, did I fix it? Nope. I think because I still have something broken here. Is alpha next? Yeah, it's this thing. Okay, so I mean, this is really convenient. I just need to turn it in. I have to actually give it, I can't call it like a function. That's right. I have to just say, I need to do a look ahead. And then if it is. But the name is sort of weird. What if I call it like check? And I can get rid of the next part, right? Yeah, I think that's fine. Now, can I use the same thing for token, like check token? And then maybe use that here. So that would kind of look like this. Check token if check. That's what it would look like. I'm not super happy with the name check though. Let's not do this yet. We'll just keep that. This is easier for me to read. Read a UTF-8 character, call it look ahead. If the look ahead is that. So I could maybe hide the char inside of something else. Like UTF-8 char could just be UTF-8 and then UTF-8 char turns. Yeah, I could do something like that, but right, I'm not gonna do that yet. Think about that. Anyway, that should have fixed this, right? Check alpha unfound. Oh, because it needs... No, it doesn't need anything. What's wrong with this? Check alpha unfound. It's right here. Why is it not finding it? Why does it think check alpha is not found? Hold on. Check alpha unfound, but it's right here. Check alpha. Line 32. Is it the type or the name? Why is it unfound? Am I not returning anything from check alpha? I am returning it. I don't get it. Do I actually need to give it a name? I shouldn't have to do that, but maybe that's a bug. Okay, that is a bug. Or is that intentional? There's some reason that that look aheads don't automatically get named after what they look ahead as. That might be the case, and that sort of bugs me, so I kind of want to put that in here as a to-do item. So, investigate why look ahead parts don't get assigned their format as their name by default. So until then, I have to be redundant and say check alpha 3 times instead of twice. You might ask, why can't I just do that? And the reason is right now my format language, I don't allow doing a parsing inside of an if statement. An if has to be an expression, and an expression can't parse anything, and for reasons. So we have to do a look-ahead parse. The fact that I have to actually name it. So this is the type, and this is the first one is the type, and the second one is the name. I was going along thinking that because in a lot of other places, by default, if you don't have a name, the name is the same as the format. So like it just the default name of the thing you parse is its format. So I could do that, but apparently I made a decision not to do that, and now I'll have to go see why. So if I want to name it that, then I have to say the name here. I could do something like X, right? That's fine. It's a little confusing to have the name twice. I'd rather do this, but I'll need to go circle back later and find out why I decided that I shouldn't allow that. Anyway, that should work now. Still doesn't like arguments, I guess. Okay, it got to the comma and didn't see the comma. Okay, so in arguments it saw. Oh, this should be not equal to. Duh. Okay, there. Now I got two arguments. Great. Two arguments are expected and name. Great. It's working again. All right, so we're done with op arguments. So op arguments is either nothing or it's something. Do we actually want to assign it a value? I kind of want to. Can I just return it as an array? So then it would be return argument. I think that should convert it to an array. No, it did not. Forget, how did I do this? The outer arguments, and op arguments. Inner arguments is an argument. And I was hoping that the value here would be the array, but it's not. I remember, did I have a built-in to do this? I don't think I did, so maybe I guess I have to build it myself. So, just say args. And then args plus equals argument. Return args. Keeps opening the wrong one. There we go. So there it is with the tooltip. You can see it is expected and name. That I would have liked to be able to return argument and have it convert it to a list. But maybe that is not a good idea. Let me think about this later. Consider converting when returning a component with iterations. to actually return a vector formed from those iterations. Yeah. Okay, so we'll consider that later. So what are we doing next? Got arguments. Statements, I guess. That's what we got to do next. All right, bite the bullet and do statements. And this is where we open the can of worms because statements, well, it's really statement. There's a lot of kinds of statements that we got to do. I think ignoring the spanned part, this is it where it might be empty, or it might have one or more statements, and it's just we need to see if it's something parses or reduces as a statement. So we're going to have to do a more advanced look ahead, where we look at all the different kinds of statements. I guess we're looking at the first token in every possible kind of statement. So a parse statement, it could be an ID, it could be a minus, it could be a plus, it could be in, it could be conditionals is always where's conditionals? It's always an if. So identifier minus plus in if while loop alt for L bracket. Or simple statement. So it could be a reference, which I think is always starts with an identifier. A reference is a ref part or another reference dot ref part, and a ref part is always an ID. Yeah, so it always starts with an identifier. A reference starts with an identifier. Or it's an increment, decrement, return, break, error warning, keep, or mode. Okay. So we have to do a very advanced look ahead. Should I? Yeah, I think I'm gonna do something like this ultimately. I'm not gonna return anything from statements though. Actually, why am I copying all that stuff? I just really need those first two lines. I'm gonna put them here. And yes, we will need to rename. We'll need to say the name 3 times. So this would be like check statement. Check statement? Yeah. Oh, this is gonna be terrible. Because we can't just look. Maybe I just do an alt here. Hey there, Sarian. How are you? I'm just gonna do an alt. Else return true or false. Return true. And we'll just do a whole bunch. Since this is a look ahead anyway, I don't really need to do a look aheads here. We'll just say it's any of these tokens. So it's either identifier or it's a token minus. Or plus. Zero idea what any of this stuff is, yet Twitch still recommends it to me? Well, I can give you an idea of what this is. I like to say that if you just jump into a stream and have never been there before, especially one like mine, that it's akin to just jumping into a lab and looking through a microscope and having no idea what you're looking at. But then as soon as you step away from the microscope and there's the helpful scientist next to the microscope saying, what we're looking at here is this. So then that only then will you get an idea of what you're looking at. Because literally I'm only showing you 40 lines of like a 10,000 line project that I've been working on for years. So it makes sense that you have no idea what this stuff is. Now, as far as I will explain what I'm doing, but as far as like Twitch still recommending it to you, I don't have any control over that. Other than I'm somewhat flattered that Twitch would recommend it to you, but maybe Twitch knows something that I don't. Anyway, what I'm working on is a program, like the title of my stream should say it's a programmable parser, and I'm doing the meta challenge for it, where the tool I'm working on, you can throw in any kind of file, and if you can describe how the file is formatted, it will format it for you. So I had this working with GIF files and with JSON files, and then someone said, well, can it parse itself? So that's what I call the meta challenge, where the format description is also the data that we're parsing. So can it parse itself? But in general, the project is you can throw any kind of data in as long as you can describe how to parse it, it will parse it for you. You still have no idea what's going on? See, Nightshade, dude, of course you do. Of course the kappa, you know what's going on. Yeah, it's expected that if you jump into a new stream that was recommended to you and you didn't know what you were getting into, you'd have no idea what's going on. But yeah, so I'm programming this in Rust with some Lua script to help automate things, and the program has its own parsing language. So that's what I call DD. So when you see the stream title says DD Rust Lua, it's because there's DD, which is my format language. The main program is written in Rust, and then I use Lua for some automation there. Sometimes in your own programming project, you have no idea. Yeah, you do generally want to know what's going on if you're the one doing it. So I hope I explained well enough without spending too much time what I'm doing. But if you have any specific questions, let me know. But yeah, in general, this is a programmable parser. I'm teaching it to parse its own language right now. Hey, Peg Poker Badly, how are you doing? And Alt F4 stream, hi. I feel like I've kind of been semi-rated there, that people have joined in. Is it the top of the hour? Oh, well, it is noon, so that makes sense. So yeah, this I'm working on basically converting the grammar of my parsing language into itself, so that it can parse itself. Well, thank you, Alt F4 stream. And I noticed that you've been doing some Rust DevOps stuff, so makes me happy. This anytime I see Rust going on, because that's how I stay. That's how I stay like motivated to do programming. Is I pick a language that makes me happy, and Rust makes me happy these days. You deep in the Rust weeds now? That's fine. I always learn something new every time that I push myself working with anything, and Rust is just kind of it hits all the right points for me. Anyway, words are hard for me. So I'm doing a big giant alternative set here, so that to check if something is a statement, we're looking ahead and we're seeing, is it an identifier, is it a minus, is it a plus? You know, any leading token in our grammar for a statement. So we need this is if while, so in if while. Oh, and I don't have that yet. So let's envision that we have a word. And I think we just need to have like, so if, what were the other ones? It was in, if, while. So Word is going to be kind of like token, only it's as long as the token. Well, what if I just make token? I don't know. I had a whole discussion there that it was hard to vocalize, but the token has a name, but a word doesn't need a name, right? But word, we're gonna have to go for the length of the word. So for can I index a string? I guess we'll see right now. For I equals 0. Forget. Do I need to have parentheses? Yes, I do. So I guess we're returning expected. If C is not equal to expected index, then error expected. I think that will be good enough. So hold on. Oh, lifetimes. I was thinking I've learned a little bit more about lifetimes recently that maybe I should revisit the videos I made about lifetimes and revise them. Have you seen the Rust videos I did about lifetimes, Alta 4? I don't remember how many of them I did. It was like a couple of years ago. So I did like a series of like intro to Rust, and I think at least one of them covered lifetimes. Maybe you can watch it and tell me if it helped you or not. I kind of feel like if I've learned more since then, I probably made some mistakes, or maybe I didn't explain it the best way that I could do. I could maybe explain it better now that I should go back and revise the video. While, okay, while, and then loop alt 4. Loop alt 4. Left bracket. L brace, right? No, it's bracket. Bracket. Like what I call a bracket. You might not call it a bracket, but I call it a bracket. And then simple statements are identifiers, which we already covered. Increment, decrement. Did I just cheat? Because I know increment is minus minus. And we already cover minus. I think I'm going to cheat and just have it be covered by that. So I just need return break. Okay, I just need a bunch of those words. Return break. Error warning keep in mode. So it is a statement if it passes that. So what do we do? If let's comment this out and make sure that it actually kind of works. So I'll just take off the look ahead and see what we get. R brace expected. Okay, the check statement was true. Right, it parsed the while. Good. But it parsed it as an identifier. I kind of wanted to check that while works, or that word works. What if I put ID at the end? And let's group the tokens together. I wanted to parse as a word. It did not. So what if I comment out ID? Okay, it's not, word is not working. Let's hack this and do word. See why it didn't parse as a word. Missing arguments to word. That's because I didn't tell it what it is. So it's word while, right? Oh, because we're not skipping the white space. Okay, that makes sense. So I want to skip ahead. Skip white space. Well, Nightshade Dude, you're flattering me that you put me in the same league as John Hu. So John Hu is a super expert master at Rust, and I am like beginner intermediate. Um, his videos are super enlightening. I'd watch his first. A word is still not parsing correctly because of why? While expected. Unable to parse word. Will it parse? Wait, why can't it parse word while expected on 197? Wait, code not doesn't match? Code 0 is, that's the lowercase w. That should match. Let's do like a warning. Expecting. Plus, and then we'll just put that there. Need to terminate my string. $119. Okay, that's not right. So I need to do a char around that thing, right? Yes. Okay, so then I need a char here. Oh, cool. So it worked. It got the word while. And it was a look ahead, so it didn't take any. Oh, wait. Why did it not? It only. It don't. Did it do a look ahead by mistake? No, I didn't. What? That should have matched the whole word. Why did it only match the first code? Whoa. WIIWLAF. What? At index plus I. For expected. I want to see. I want more printf statements. Wait. So it didn't see it? I'm confused. Oh, because this whole thing is inside. I see what I did wrong. This whole word while is inside of a check statement. So really, I want to, if I wanted to debug if word is working correctly, I want to put it. Wait, check statement isn't look ahead. So wait, that should have worked then. Why did it only parse this, the first? Oh, did I have an equals not equals problem? Oh, I had the return too early. Duh. There. It's always something. Okay, there. Now we got. No, we got an error with the word. Will it parse? Okay, it stopped on a white space character. Oh, wait. It's out of range. That's right. This should be divided by 8 because length is supposed to be always length in bits. Cool. So we parsed the word while. Okay. Now that I know that word works correctly, I can get rid of the warning in there, so that we get rid of that stuff, and so get rid of the special word that I expected there. Okay, and then what do we get? So it does see the word while. Okay, cool. Then we want to turn this into a plus, uncomment this, and now we have to handle all those cases. Actually, if I know what the case is, like if instead of just returning true or false, if I returned what kind of statement it was, I can uncomment that. Then I don't have to check again. So why don't I do This is gonna look crappy. Return. Can I just say token? Oh, I know what I can do. I can just name all of these things, right? First. And return first. This will return nil. And then we can say if, so if is always true for a non-nil thing. Our first unexpected on line 57. Oh shoot. I can't put that there. I have to do this way. Could not determine if condition in alternative 1 was true, and it'll determine if while indicates true or false. Okay, so then I was wrong about that. This has to be if it's not equal to nil. Okay. So we're back to wait. Did it oh, it did skip it. Well, let's do warning. First is I can actually name this something better. First token. First token. Yeah, that's just fine. First token. It's not really a token because it could also be a reserved word, but that's fine. First token. First is while. Okay, cool. Then let's get rid of that and put that there. That should match that. So this is highlighting the white space before the while, but it's showing the first is a while. Okay, then I think I just want a series of if-elses then. So if first token is I'm going to have a lot of these now. I'm basically going to do all of them, aren't I? While loop alt or Return break error. Warning. Mode, keep in mode. And this shouldn't happen, so we'll do an error. Unexpected first statement token. We should never reach that point because I think my checks are exhaustive here. So if I did this right, then we should reach here. We'll just do a warning. While loop detected. While loop detected. Nice. So we just need to handle a while loop. So easier said than done because a while loop depends on a whole bunch of other syntax. So expression is a huge thing. The benefit though is that this is all already handled because we handled that for statements, right? So I just need to handle expression. I don't need to handle all expressions. I can just start with that expression, which is a binary operation with a sub-expression. Yeah, so we'll just I think I'll handle it minimally, and then I'll just to get it to parse itself, and then we'll have to handle the cases where its self-description is not using some of the grammar. So yeah, so what? I guess we'll just say while. Oh, and I can't use a reserved word here, so while loop. While. Can't use a reserved word there either. Just call it while. What if I just have an underscore after it? Okay, so while will be word while. Cool. And then it'll be expression. And then it's the same thing as statements. Or the body of ops statements. Where was that? Op arguments. No, it was it's actually just here. So it's while expression left brace statements right brace. Okay. So then it's expressions next. And yeah, here's where it gets really difficult. How about KW while self-documented? I mean, that's the same idea. Like in Rust, you could do R pound in front, but I don't have that in my syntax. So I was just thinking, I just need some convention that says, well, it's like, just ignore that part because I needed to have it to distinguish it from a reserved word. So your way works too. It's just that KW is now, KW underscore is a different convention, that's all. But I think the one reason I kind of don't want KW while is that this is not just the keyword while. That's this part, right? But it's the whole while loop. So if it's the whole while loop, that's why I sort of like, I started doing like while loop I can call it while loop. I already built a language parser. I'm having the parser parse itself now. So the language parser is all described in Lollipop grammar. So this program right here already has that grammar all built in. It just doesn't know how to parse itself. So I'm trying to convert the grammar into its own language so that it can literally parse itself. Because that's Alta 4, that's the meta challenge for any language, is can you have the language understand itself? So like if it's a C compiler, can the C compiler compile itself? Can the Rust compiler compile itself, right? The language itself is for parsing any kind of data. So like here's an animated GIF description. So kind of hard for me to switch back and forth, but I'll do it once just to show you. So if I open the GIF config, then I open a GIF file like PogSlide, and I click on one of these, you can see it's parsing out the individual frames of the GIF file, right? And in the logical screen, we can see the width and the height. And if I click on a byte like GIF, that's the signature. That's because it's all described in this GIF format. So there's that logical screen, or the header contains that signature we just saw. The logical screen has the descriptor with the width and the height in it. And the magic of how I get all of the individual frames out, there's quite a lot to that. Just delving into these, just to show you, here, let me expand out this way so you can see it. Keep that up just so we can show you that we're really looking at an image. So this one right here, a rendering block has image data, which has an LZW code stream. Well, really, they're blocks. And so there are like 33 blocks here, and each block has a size and then just a bunch of bits. You're supposed to take all those blocks together, concatenate them, and then interpret them as an LZW code stream. That's what this does, and it's like it goes through the stream one code at a time, and for each code you get the encoded byte, or the encoded bits, and then the decoder output. So the first bits are 9 bits that are 255, and the output is one pixel, index 255, and then next one is 258, so that's 2 pixels. 259 is 3 pixels, etc. All the way down. So the image, it's 112 by 112. It took 5,994 codes. So we're doing the full decoding of the image using LZW decompression algorithm, which is actually not too bad in my format language. Here's what it looks like. So it almost fits into a page, but not quite. But the core of the decoder is the reconstruction and extraction of codes from the code table. So you have an initial table, which is just a one-to-one mapping between input and output for the first 256 entries, because the minimum code size is 8. So 1 shift left 8 plus 1 is 256, right? Or 257, because you have some reserved entries in there. Anyway, you have that table, and you're building it incrementally by every input code adds to the table. So where do I add to the table? Well, here, when you get a clear code, you go back to the initial table. If you get an end of information code, you break out. But yeah, in here, I guess in there I update the table. Yeah, see this table place equals last. So you're always adding something to the end of the code table. That's how you get these run length things, where like if you have a run of 255s, you're actually building that run into the table so that it builds on itself. That's why GIF is really good for artificial images that have long runs of the same pixel value. So down here, it's like it's a whole bunch of 255s in order, and so that gets very efficiently coded. I've been meaning to have it where if you click on one of these nodes, it actually highlights the pixels, but I don't have that yet, so you just have to imagine that for now. Good evening, ICS Boy X. Yeah, that's one example of how my programmable parser is taught how to parse animated GIFs. Hopefully that makes sense. Today, I'm having it parse itself. Did I flew far Did I fly far over your head? Well, you understood the very basics, right? If I collapse it to the top level, and I show you the top level of GIF, and it says GIF has a header, a logical screen, loop with a bunch of datas and a trailer, and we know to break out of the loop if we look ahead 8 bits as an unsigned integer and it's 3b, we know to break, right? That's exactly what this is. There's a header, and the trailer is a 3b byte at the end, right? So it knows that data ends right when you see that the next byte is a 3b. But yeah, header is composed of signature and version because header has signature and version in it. If statement doesn't do any parsing, it's just doing a check, right? So there's two child nodes of header. And signature is a built-in. That's a string of 24 bits. So that's the string right there. And then version is really just a decoration over another 24-bit string because we parse it and we name that encoding, and then we check is the encoding something or something else. That's why here in version, the encoding is 89A, but we interpret that as 1989 because of this if statement. And then it just proceeds from there. It's like it's compositional. It's building blocks that build on each other. Like logical screen has a descriptor and a color table because that's how I just defined it down here. Logical screen descriptor and then a color table if we have one. So it'll leverage the first thing it parsed to look in and see is this flag here not 0? Well, then we have a color table. So it sees that that flag is 1, so then that's why it parsed that. If this was 0, it wouldn't have parsed that at all, right? Parsing anything that can be defined. There you go. Nightshade Dude's got it. So next time someone asks what this does, is this parses anything that can be defined in my parsing language. Oh, thanks. We're 888. Yeah, I'm working on having it parse itself. That's why I call it the meta challenge. I think I am just gonna call it while loop because that looks better. So rather than it being a GIF, we're having it parse itself now. So we're gonna load format. It's gonna take me a while because as you can see, there are a lot of different kinds of statements that we need to describe. And I'm just trying to get through the very first one. So there's, at the very top of this is we have a while loop. So I want it to be able to parse this, right? So we need to teach it how to parse a while loop. We need to separate the keyword from the expression from the statements, right? That's what this while loop does. It says, well, there's a keyword, and then there's an expression, a left brace, some statements, and then a right brace. We did word already. That's why it can see the word while there. It just doesn't know how to parse the expression yet because I haven't put anything there. An expression is really complicated because now we're diving deep into the grammar. Like expression is like half of my part of my grammar. There's all sorts of different expressions. But I think we're going to start with the basic kind of expression. And I'm going to have to do the same trick of order of operation. This is how you do order of operations in Lollipop. You have a whole bunch of different kinds of expressions, and then you layer them on top of each other. And you see how there's an 11 on the left and a 10 on the right? That ensures that it's left associative. So like this is always a higher order expression, and then a 10 can never be an OR expression. So if you have A or B or C, it's always A or B and then OR C. You can't have A or B or C because expression 10 can't be an OR statement. If you really wanted to do right associative, you do parentheses, which is way down at the bottom. There's an escape hatch for parentheses. Right here. The escape hatch is from the lowest level expression. You can get back up to the top by putting it in parentheses. That's a little trick there, how you do order of operations with Lollipop. Oh, God. All right. So I hope if I have completely lost you, at least you can go along for the ride like on a roller coaster. Maybe you'll get something here and there, but yeah. Like I was saying before, it's kind of like looking at a 40-line microscopic view of a 100,000 line thing. Yeah, this is going to be a lot of typing, so I'm just going to focus on the one I care about. So in this case, it's binary expression, right? So we want some sub-expression greater than some other sub-expression. That's way down here at right here, expression 4. So we're going to cheat right now and say that an expression is an expression 4. We'll fix it later. Exper 4 is... We're just going to say it's always a greater than. So it's an expression 4 greater than an expression 3. I have to be careful about this, though, because it'll recurse forever if I don't do this right. The way Lollipop does it is it does shift reduce, but the way my parser works is it's just following it. What's the word? Like imperatively. It's like expect this next. I think I actually can't build it the same way, can I? Yeah, how do I do the recursion here in my language? This syntax? I'm not sure, but it's the syntax defined by the Lollipop crate. But this is a technique in that syntax to do nesting. And you see how it's recursive? It's recursive because it's using a token stack. It won't go forever. It has to actually match and basically it's shifting in tokens like the less than gets shifted in. It says, okay, we're right here at cursor. We're here within an exper 4. We're between this left hand and this right hand. So it'll expect to be able to reduce the next tokens to an exper 3, and when it does, it reduces this whole thing to 1 exper 4. So the whole token stream gets ultimately matched against these rules and reduced all the way to the top syntax, which is formats. So we're going from a long token string down to one token called formats, which yields a hash map from string to format. And we're deep in that when we get to exper 4. So like, we're looking at like, while remaining is greater than 0. So if I looked at it from the bottom up, we have the remaining is an identifier token, and then we have a left parentheses is one token, a right parentheses is another token, greater than is another token, and 0 is a literal integer, right? So how that gets built up in the grammar is from right to left, that 0 is a unsigned integer. So that'll get matched as an exper 0, right? And exper 0 it will get reduced to exper 1, which will get reduced to a 2, which will get reduced to a 3, because it will have seen the greater than, because it's trying to reduce to an exper 3. So that 0 ends up showing up here, and then the greater than 0 is that part, and as long as that remaining parentheses gets reduced to exper 4, it'll work. And the way that works is, again, going down, identifier left parentheses expressionless right parentheses gets reduced to an exper 0 as a function. An exper list can be empty. That's allowed to be empty, right? So that's an this is an exper 0 because it's a function call. This is an exper 4 because we have a greater than, and that's an exper 4. A 0 can stand in as a 4, so that's a 4 and that's a 3, but they're all zeros. I'm not explaining it very well, but I hope you get the point of how remaining function call greater than 0 gets gets interpreted in this grammar is through ultimately through this rule here. It's an x per 4 that comes from another x per 4 greater than 3. And the left and the right hand, ultimately, they're x per 0s. One is a function call here, and the other one is a literal unsigned integer. Yeah, this is gonna be hard. I don't know if I can actually mirror the grammar because of the fact that it's recursive, the way in which it's recursive. If I told my format language that expect an x per 4 here, you know what's going to happen is it's just going to go into an infinite loop. I don't even want to save this because I'm not sure what will happen here. It'll just go into an infinite loop. If I say that it's empty, it'll end there. It'll say L brace expected because x per 4 is empty. I think I need to structure this completely differently. I gotta like turn it inside out almost, don't I? I have to start from the bottom and I have to look for these tokens. Don't I? Yeah, don't I need to do it inside out? I'm asking myself. I think so, because I think we're gonna need, if we're parsing it from left to right instead of inside and instead of top down, so to speak, I have to go by, yeah. Yeah, I think you guys are right. Can you do precedence climbing? Since my format language is strictly left to right, I can't describe it in terms of precedence or, well, maybe by precedence climbing you mean something that I don't know what you mean. But I can't use the same trick of shift reduce grammar rules. Yeah. I'm gonna build it from left to right. So I'm gonna say that an expression has to be has to at least start with one of these. Well, don't I need to do a same kind of look ahead? I think I need to do the same kind of look ahead. I have to say like yeah. It's gonna be like check. Maybe I just do an alt directly in there. What if I just make it work for the expression I have now, and we'll just build it from there. So what it's going to be looking for is this first thing, which is an identifier. And we're just going to assume it's a function call. So why don't I just say we expect a function then? Function call. Down wherever we were. Function call. And then token greater than. And then I can have an expert here, right? Or well, let's just keep it. Let's not do recursive yet. So unsigned integer or literal UI. Okay, we'll do these one at a time. So function call literal UI. We'll just say that this is. I'm already getting tired. UTF-8 char. It's a single character. Oh wait, I can steal what I did for JSON, right? It'd be pretty similar. This is more than I need. Can I just... Let's do this. Whoops. Didn't mean to do that. Sum is 0. First is true. We're not handling decimal points, so I'm going to delete all that. There's... I didn't need that. There's a digit or else break. First is false. Sum is... Yeah, then return sum. And I just need digit. And then this was char C, because then I can do... Actually, I'm just going to keep it the way it is. Two hours, 15 minutes on the stream. Okay, function call is an identifier. And then eat white space. Don't I already have something like this up here somewhere? Well, let's just make it match. I'm just gonna make it match right now. I will need to eat white space in spots though, actually. I wanted to match that first expression. Function call remaining left. Can't see all the hex. There we go. So there's the while loop. Greater than 0. Okay, so I need a little bit more white space trimming. Here. Okay. Okay, so it's getting to where it expected a right brace because it thinks it's a while loop. Not a while loop. So wait, what? Oh, it couldn't parse that. So it's getting down to the statements and skipping everything, right? Right, because it's entering this it's getting here and it's getting to this identifier, right? I don't even have a case for it. Check statement. Check statement should have returned. Oh, that should have been first. What's an ID return? Is it just return a string? Yeah, so then this else is going to be identifier. So we're just gonna, I'll just put identifier in there for now, and a semi. I don't have a semi. Oh, that's token semicolon. Okay, so it reduced statements to nothing. Why did it do that? Wait, it saw a 4? Oh, it saw the FOR in format. Oh. It should only match that if the next character is is non-alphanumeric, right? Yes. Okay. I think the way I did this in the Lexer is token, I think implicitly like checks to make sure that the next character is skipped or something. Or actually, I'm not sure how it works, but I need to handle that. Ugh. In Word, right? So it should be like look ahead UTF-8 char. Or actually I should just do a look ahead alpha. Alpha num. If uh I don't I think I want an alt, don't I? Yes. But it can't be a look ahead. So this whole thing needs to be a looked ahead. Like is alpha num next? Or I had to check alpha num. Yeah. Check alpha num. Just put that in there. Okay, and then it would be how did I use the check thing again? Like this. Okay, and then for word, put that there. Check ahead. If then it's an error because it's not that word, right? So I'm just gonna repeat this error. So the FOR in formats should not match now. Okay, so it saw format as the first token. Great. So I want that show up as an identifier, and why is it not? You know, maybe I'm making this more complicated than it needs to be. This check statement thing. Like, these are all identifiers. They're just special identifiers. The only reason I needed to make them special was that they needed to be special in the grammar, but I really didn't. I could just delete all this right now because ID will match it as well. I'll leave it in there for now. So we should be getting here. Well, it should have reparsed it as an ID. Why did it not? Oh, it is. There we go. Okay, so it's just it's not skipping white space at the end. Okay, so wait, statements is one statement? Shouldn't this be in a loop? I don't need this. This should be in a loop, right? Yeah. Yeah. Okay, this needs to be in a loop. So, loop. I need to check for, I need to explicitly check for the right brace. Hmm. I guess I could check that at the end. Well, actually, I know I actually know what I need to do. I just say if it's null, then break, and then outdent that. That should work. Uh-oh. Oh no! I think it's infinite looping on me. Okay, I have an infinite loop here. Oh, I think I might know why. Shoot, I think we need to break on all these things for now. Because I'm not handling them yet, and so it won't parse anything, so it'll keep trying to parse it forever and never get out. Actually, instead of break, what if I actually do an error? That would be more appropriate. Not handle to do. Need one for mode. There. Make sure. Okay, cool. Back. All right, so couldn't parse that because to do. Okay, what was to do about that? Oh, okay. It's the next one. It's the ignore. Okay, so then we did. Okay. Sure. Oh yeah, it's gonna look funny there unless I put this entire thing as statement. Yeah, I'm gonna do that. So I'm gonna have this whole thing be another thing called statement. First token. And then I do this statement. First token. That should re-show this as there. Okay, statements should be, there's one statement per loop. Yeah. Okay. Is this IM hex? You mean this? No, this I made my own hex viewer. But it's a overall the overall program. This is just one view of the data that we're parsing. So this whole application is a data parser, and the top left panel is just showing the original file both in hex, a decimal, and an ASCII. And on the top right panel, we're showing the output of running this input file through a parser and generating an output tree. And the bottom is just log messages. So overall, we're making a tool that can parse any input file using a format description, which is written in my own language. And kind of hard for me to switch gears from what I was working on to describe this overall, but I'll do it really quickly. So, for example, here's another thing it can parse, which pretty much done. This is parsing an animated GIF. So these are the individual frames of the animated GIF, right? You can see them pop up there in that viewer down below. Here is the recipe on how to parse it in my parsing language. So here it says GIF, header, logical screen, data, and trailer. So that should match this top level of the tree. So there's the header, there's logical screen, there's the data, and there's the trailer at the very bottom, right? Logical screen has a descriptor in it, which has width and height and stuff like that. And you'll see that down here. Logical screen descriptor, width and height. So my parsing language is inspired by the MPEG-4 standard, where if you ever looked at that, they describe their formats in a C-like language, where the statements of the language are either parsing an individual field of bits or it's compositional. So like it's a higher order thing. Like header is a higher order thing because it's got a signature and a version. And the signature is just a string, but the version has an encoding that has to be interpreted. And that's what you end up here under header. Signature, and there's the encoding of the version, and overall the header. It's all hot reloadable because the GUI is watching the files in the background. If any one of them changes, it reloads everything. Yeah. So yeah, today I'm working on having it, since I already have it parsing animated GIFs, which is pretty cool. Rather than going on to another image format, I thought, hey, let's do the meta challenge. Can it parse itself? That's what I'm working on right now. So FMT to FMT, right? It's very meta. It's the format on how to parse its own language. And I'm already kind of getting hung up on. Oh, that's weird. The POG slide made it in. I'm already getting hung up on that there are lots of different kinds of statements and a lot of different kinds of expressions. So we have at least one kind of expression, which is if it's a function call and greater than a literal, it knows how to parse that. But yeah, there are a lot of different kinds of expressions and kinds of statements that I have to handle, and a lot of them are marked to do right now. And yeah, this is also to do because this is one kind of statement that starts with an identifier out of many. So right now it's getting hung up on the second statement, which is this, which is a look ahead. How about we say something like to do ignore, to do look ahead, to do bounded statements, do inner parse, do conditional. We sort of have while loops done, so do loop, alternatives, for loop, return, break. Actually, I can probably handle these. I can handle break and error already, right? Well, no, I can't handle error or warning until I handle string. So this will at least print out like, yeah. So it couldn't see this, it couldn't understand this statement here, which is an ignore. We love a PCAP file parsing tool with network monitoring. That's called Wireshark. I thought about having my tool work same way as Wireshark. Problem right now is that the tool has to load a file, so you'd have to like run pcap, capture to a file, and then pull it into my tool. So another way to make it more like Wireshark is if, in addition to files, if it could just listen to network ports. Hey there, Ramy. Wowee, Ramy's here. The artist, currently known as Ramy. You're marked as an artist because you made this art, right? You'll forever be known as the artist currently known as Ramy. Okay, back to what I was doing. Yeah, if we do ignore statements next, I'll just cheat. Actually, I'm just going to pull this out right now. So this is a parse statement. Hold on a sec. I'm back. Cat got out. We had to get the cat, bring the cat back inside. Want to specify the frame format with the descriptions in a tool like mine currently building IM hex plugin to achieve it? Oh, okay. Well, mine is probably way overboard because mine is very open, defining its own language and etc. So, for what if you have a very specific thing like tailored around parsing packets, then you might be able to make something a lot simpler than what I'm doing. So an ignore is got an extra token in front. Actually, it doesn't have an identifier, so it's just minus. Oh, it does have an identifier. Yeah, in fact, well, parse is not complete because it also can have arguments. So haven't gotten quite there yet. Oh, I didn't link it. To do is ignore is still to do. This is ignore. So that should parse as an ignore. Okay. We're very nested now. Oh, and there's that display bug. That's on my to-do list to fix, but I haven't fixed it yet. But yeah, this is going to be very nested for a while. Collision on token. 117. Oh yeah. This is minus. Well, ignore. And then semi. Well, can I just call it my? I don't know. That'll work. Okay, cool. So we have the ignore statement. Oh, did I not do the regular? I did not. So this should be parse. So we have a parse and then ignore. And then our brace, okay, it got all the way out to So format 0 is completely parsed now. So on to format 1. So its statement, semi was expected. What did it end up trying to parse? A parse statement. Okay, because this has got two identifiers. It got to the n and said, oh, that needs to be a semicolon. So yeah, that means there's an optional name here in right here. Optional, what is it called in the grammar? Our statement, optional ID, which is the name. Okay, and then optionals. I should try to group these together. I have optional white space. I'm also not consistent with the naming. Where to put this guy? Maybe here? Optional ID. So yeah, it's either an identifier or it's not. So how did I do, like, I'm already forgetting how I'm doing things. I did a look ahead. So what? I look ahead and see if it's an alpha character, it's an identifier, otherwise it's not. Yeah. Is alpha, right? Check alpha. This. So it would be this just needs to be alpha. Whoops. So it would be ID. Return ID. All right, we're getting further. So there's the parse is the identifier. Oh, that should be format. Yep, lollipop. So when I'm looking at the lollipop file, it's using the lollipop crate. This is the grammar for my language. So basically, it's giving rules on how to take in an input token stream and match them against grammar rules to reduce them to the output compiled version of the format. So this is the input, right? These each are formats. The top level grammar is format. So ultimately we want a map from string to format, and a format is like a bunch of statements associated with a name and arguments. That's what these don't have any arguments, but like that's the name format, and these are the statements that go with format, right? So when it's able to assemble a bunch of either, there's a mix of tokens and then sub rules that have already been matched. If it can match a whole bunch of statements and then match braces around it with an identifier in front, then it'll reduce that whole thing to one format, and then that ends up getting added to the map that's output here. So yeah, I was gonna go to parse and give it a name. Yeah, this is format. This should say the format is ID, the name is name. Token, we should just call that semi. Semi. Okay, so there's our parse statement, and then another parse statement, and then another one. Actually got all the way to the return statement to do return. Okay, cool. So return, let's do that one. Return statement. Yay. That's going to be the word. Why am I typing it when I could just copy this stuff, right? Just going to be word return expression and then semicolon. Okay, and then it's going to have a problem because the expression doesn't match anything it understands yet. I have commands. My bot doesn't know a whole lot of things. I don't know if I've updated the today thing. I think it's just generic. Yeah, no specific goal. How reusable would you say the tool is of the state or anyone that isn't me? You would have to know how to use it. I don't have good documentation yet. So I was working on that, but it's very far behind. So if I show you, I do have a README. It has a very high level overview saying, well, here's an example, and it actually goes through what that means. And like, here's how you do a color table, for example. But even this is like not the right way of doing it anymore, and I would do it differently. And it goes through the different modules, and it's missing some because I think the last time I touched this file was like a year or two ago. Okay, maybe not so long. So it's been like 3 months since I touched this file. Feels like a year though. So it's just the README file is very short, and it only has a high level description of the modules, and that's only for the developer point of view. For the user point of view, it has a short description of it, but it's not very deep. So it's just not documented very well yet. Yeah, my bot doesn't like a space in between the bang and commands, but if you did capital commands, it doesn't work because it's case sensitive. You have to do commands. Yeah. My day job, can't really talk about it because of job rules. I can say that I'm a software developer, but I don't use Rust at work very much. Well, sometimes I use Rust for if I need it to make my own tool, but the code that I develop for my job, it does not use Rust. Yeah, but job rule number 2 is basically I'm not supposed to talk about work. It feels like Fight Club, you know. Not talk about Fight Club. Vim or Emacs are not at all tied to experience, though. You're answering someone else, right? Oh, is that a joke? Because, well, at least Emacs, it's like the editor you can't just jump in and start using, right? It requires like some learning, some training. Okay, I need to teach this now that an identifier is a valid expression. So here for identifier, I have that it could be a function call. So that's if the identifier has, I think we just need to look ahead. So we need to say like, if there's a parentheses after the identifier, it's a function call. So like, if, we'll look ahead, why don't I just say look ahead, like I did for the statement. Check, I have a check thing, right? Did I just have check expression? Well, that only needed to look forward one word though. I think that's fine though. We'll do a check expression. Back, I can just call this thing check, right? No. I'll check expression. If let's work again. Like well, it's function. Ref. We'll have this one bail if it's not right. So this is function. Actually, I should that should be function call. And it should actually be looking ahead more, right? Oh, this is going to get really complicated because it's going to have to look after the function call to see if there's an operator. And if it's an operator, it's like, oh, okay, it's a binary expression. First, parse a sub-expression. Yeah. Anyway, I'll be right back. All right. Aha, you've used my OS and keyboard commands. So it's like, has it been a couple of years now? Check out that video is a pretty, I like that video. I was showing it to someone else. But here's the keyboard. I still use it. Made this on stream here. I actually have a second one. You know what's really cool? I can't show it on my screen. But I found that a makeup bag fits the keyboard really well. You just put it together and you put the whole thing in a makeup bag. Easy travel case. So this is going to be complicated because we might see a function call, but the function call might be followed by an operator. So I wonder if we have to do something like scan ahead until, well, we need to see if an expression might be the left hand of an even bigger expression, right? I think the only way I can do this is with a whole bunch of look aheads, and not gonna be pretty. Let's see what I can do though. So this is gonna be a lot like the check statement, right? Where'd I put that? Yeah, a bunch of alts. expression expected. Okay, and then yeah, why don't we try to do the eager thing? So it would be like we try to parse it as a function call. So it would be function call. And if it succeeds, we return function call. In fact, that can just be one-liner. And then if it's an ID, we'll just, if it's not a function call, but it's an identifier, we'll just say it is a ref. And then that. Okay, and if it's a ref, oh, that's not correct. Not function. Shoot. Have this. That is a function call, although missing to do argument expressions. Right now we don't support that, but this I need to have in here. Yeah, why don't I just do alternate? I'll just leverage the alternate thing as like it's greediest down. So this would be like binary op. If it is 1, then return binary op. Because I want to support this as a binary op. Oh, thanks, Origami. I mean, that's the culmination of like months-long work. But this keyboard is actually not that bad as far as like a first project involving some 3D printing, some PCB work, and some firmware. Actually, anyone who asks me now, like, if I want to get into embedded software, hardware stuff, I want to make my own, computer-related thing, I'd say make your own keyboard. Okay, see you, Origami. All right, so yeah, where I was trying to get to with this is I want this to become binary op. Right now it's hard-coded just to match that, but that's all I really care about. It's the how I'm gonna nest is the tricky thing. I'm probably gonna end up doing what I do in the grammar, right? There's gonna be different levels of expression all the way down. I'm probably gonna end up doing that. Let's see. Will it work now? 339. Token left brace while loop. I thought something was a while loop. Getting this far. No, nope. Nope. Oh, yeah, okay. So it got the word while. It couldn't parse the expression in the while. Okay, I know why. So it probably got binary op, and I don't have a check for that. So You know, this almost seems redundant to me. Maybe this should just be expression, and I have a whole bunch of alts, and it just tries the most greedy it can. The downside of this alt is that it won't catch it won't catch syntax errors, or it won't catch parsing errors. And I kind of want it to. Oh, okay. One way to do that would be like that. This is like a check binary op, and check binary op is like binary op, only it only gets this far and stops and doesn't do this one. Yeah. Yeah, I think I want to do it that way. So there's going to be a check version of each of these. Which just goes to that and stops. But yeah, as long as it parses successfully, right? Yeah, okay, then I need a check function call. Which just goes to the left paren. Exactly. And this is all forward looking. It's all look aheads anyway. Okay, I think this will work. Did it? It sort of did. It did. Sees that while loop. All right, and inside the while loop, we got binary op. Function call, should name that op. Roll UI. Okay. And here's the statements of parse and ignore. Okay, good. Okay, great. So we're off to the second thing. Okay, so it saw a parse statement, another parse, another parse, another parse, and then failing on the reference. Unknown format ref. Okay, good, 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 good. I put ref after function call. Okay. I'm gonna check ref. Probably. A ref right now, I think I can just get away with an ID. Cool. So now we have return statement. We have the word return and then the name. Return name, semicolon. Cool. So we got two formats parsed. Now a third one. Look at it. So it doesn't know the look ahead. So there's an ignore and then there's the look ahead. So look ahead is just like look ahead is like a parse with an additional thing. Okay. Where's ignore? There's okay, look ahead belongs right here, right? So it's gonna look like parse, but with an extra plus in front. A plus in front. And then the look ahead has to actually be linked in there. Look ahead. Okay, cool. So let's see how far it got this time. Ignore, look ahead, and then we have, okay, if statement. So it's going to be if expression, and then, okay, we can do this. So condition if statement. Kind of looks like a while. But it's if expression optional white space left brace So we don't handle the else yet, but let's see how far that gets me. Okay, it didn't like that expression because it expected a right paren. Oh, the function, it doesn't like function call. Yeah, okay, so we have to actually allow an optional expression there. Uh, function call, right, is to do. So, optional expression. Actually, it's an optional expression list. Expr list, what it is. Yes, expr list. Okay, where are we gonna put that? How about right here? And it's kind of like the argument list, only they're expressions. So where do I have argument? Here. So there's it should be like check. I have a check expression yet? Yes, I do. Not equal to nil. Then we get an expression. So that would be I guess it's just expression. And am I building the expressions? Expression return anything? Doesn't yet. So I'm just going to leave that part of it out. Well, I kind of want to see it though. Nah, that's okay. We don't need to see it. So expression optimal white space, you might have a comma. Okay, good. If that works. Okay, we got. Okay, the function call worked. So it's got expression list, which has single expression, which is a reference, which is look ahead. Nice. Okay, so we're not handling comparison. They handle comparison. And now I have to start getting sensitive about order of operations, right? So where is comparison? That's level 5. So that's one above greater than. So it means it's the outer one, right? So we check for that first. Okay. So yeah, I think I have to start numbering these. Unfortunately. Uh okay. Yeah. So we'll do so binary op is actually expression 4. So what I'll do is I'll just say I'll just leave it the way it is. Um, check expression. We'll do check. Actually, I think I'm just going to replace this with exp4. xpr4. A function call is x per 0, isn't it? Sort of. I guess it is if we can look ahead. I don't know. But yeah, the 4 is going to tie me to this grammar because then we're going to add a 5 in addition to the 4. Yeah, okay. So then I need to add a 5. As long as we do this in decreasing order, it should work, I think. Wait, am I making a copy by mistake? Yeah, I am. This was supposed to be 5. This is supposed to be 5. I can call that, remove the 5 there. If it's a 4, okay. This one's 4. Okay. It could be level 5, level 4. Level 5 can be a 4, so I don't really need to have a... 5 doesn't need to check for 4. Oh wait, it does. Oh, how do I do this? Do I remove this level? Help me, I'm in expression tree hell. You know what? I named them their numbers, but I don't really need to keep those numbers, do I? Well, sort of, because it's not always like I could call this one equality, and I can 5 is equality. I can call 4 inequal, like order, and 3 is like addition. But then when we get to here, it's like this is 3 different things that each have their own name: multiplication, division, and modulo, right? So maybe I stick with the numbers. I think the way I'm going to do this recursion is it's just going to loop, um, where it's just going to match like expression 4. It's like expression 4 equals, and then a chain could be a chain of expression 4s. This I could leverage the recursion here, and it's not infinite because of the shift reduce rule, how they work. So yeah. Okay, I know what needs to be done. It's this followed by one of those operators. So then it's really expression 4. It has to be an expression 4 followed by either the greater than, yeah. I think that's all I have for now, right? Either that, and if it is that, then it returns an expression 5. Right. Have these mixed in a weird way. This should kind of go above expression 5, right? So check if something is an expression 5. You have to have an expression 4 followed by a greater than, and there's going to be other alternatives. Actually, I can just move this down to here. So if it parses as an expression 4 followed by the greater than, then it is an expression 5. And so when you parse as a 5, wait, why are we doing the check there? I'm confused. This should just... Yeah, I think okay. Hold on a sec. I'm back. Answer a quick question. If we know it's an expression 5, we don't need to check. So I don't need to do this stuff, right? I just... Yeah. Don't I just... Yeah, okay. I think I know what to do. So we still have the alt there. We don't... So here we would actually have to... We have to error. Binary operator expected. And then an expression. And then here's where I need to have this in a loop, I think. Oh, I know what I'll do. We won't get to an expression 5 unless it passes this check, right? So we can just then do a loop. Where we have another expression 4 here. Right-hand side? Well, or arg. It's the operand, right? Or right-hand side? It's just that if you have like A less than B less than C, it's gonna call that that's the LHS. It's gonna call that LHS and it's gonna call that RHS0 and RHS1. Do I really care? So rather than using recursion, it's just using a loop. Alternatively, I can make it just chain on expression 5 on the right. Maybe that's better. As long, okay, it could either be another expression 5 or an expression 4, right? Yeah, so, okay, then that's what the grammar says. I'm at the wrong level, by the way. 5 is equal, not greater than. But anyway, The last one has to be a 4, but the one up to leading it could be more 5s. So how do I do this then? So it's really equality we're chaining. So the 4 can't be that. So if it's a 4, it's just the A, right? Uh, right, and then the equal. So I don't have the. What if I call it? If I call it word, it'll actually work. I need to combine word and token. Hey there, Sir Elfman. Looks like the parser you wrote, except use proper names instead of expression 5. Yeah, I think I was just lazy. The problem, like it's easy to call expression 5 equality, but when you get down to like 2, where it's division, modulo, or multiplication, then what do you call it? Like expression multiplication or division like thing? So I'm like, I have trouble with words. So I left them as a number because it's really the level in the table of operator precedence. So the innermost is 0, and the outermost is 11, I think. Yeah, 11. So it's just my table of operator precedence. I know what I'll do. That's a 4, but then this whole thing is a 5, right? And I don't care about the left versus right associativeness. I really mostly care that it doesn't infinitely recurse. So then, yeah, then this is a 5. And then I don't have a loop, because I'll let it recurse like this. Yes. Okay, so then I determine 5. 5 is defined. Okay, so then I can just enumerate these already. Equal and not equal. And then parse term, parse comparison, parse factor. Okay. Yeah, I mean, I could probably come up with better names eventually. I'm just terrible at it. So like this is order. This is equality. Plus and minus would be like addition, or what would you call it? So it's addition, subtraction. I need a term that fits both of those, right? And so this would be factor, I guess, what you're saying, right? Factor? Summation, but is minus summing? Minus is sort of a special case of plus. It's like negating the right-hand operator and then doing a plus. You can think of minuses in terms of it's a syntactic sugar around a plus with a negation. Yeah, exactly. Sum of plus with a negative number, right? But when it gets to like where like modulo and division are the same, but you're returning one of the two things you get out of it, it just gets weird name wise. So I just stuck with level. Okay, so I don't need this else, right? Because we've already checked. So then it's just alternative, right? So then expression 4 is, well, that's the deepest I got, right? No, it's not. We wanted expression 0. Expression 0 and then one of, yeah, it's the same thing here. In fact, I'm going to do the same thing. We have word. I think I'm going to call word token and get rid of the old token. So yeah, the only difference between these two should be that the check parses far enough to see that it must be an expression 5. it sees it sees a valid expression for, and then it sees either equals or not equals, and it says, okay, then that is an expression 5. And then when we actually go parse it for real, we do the same thing, but we expect one this time. So this will all follow the same thing, right? So this will be an alt again. I'll just leave it at, I'll leave it incomplete. Return nil. So an expression 4 will be an expression 0 followed. So an expression 0 is a function call, which I already have. Okay, yes. Did you seize preference for bitwise stuff? I think I did. That's at the right here. Inkle excal mask. That's inclusive or, exclusive or, and. I hope I got that in the right order. So they're lower precedence. So it's inverted, right? So the higher precedence is at the bottom. The highest precedence is like not, and then bit flipping, negation, and then parentheses is the escape hash to get to the other end, and then like the leaf nodes, and then you have left shift, right shift, and then multiply, divide, then plus minus, then ordering, then equality, then the bit bitwise stuff is and then exclusive or, then inclusive or, and then I have set what forget what in means. Binary operation in. Oh, this is a set, a special one for sets. If something is in a set, I think. And then this is logical and logical or is the very top is logical or. You have thoughts on parser combinators or invertible parsers? No, that's way beyond me. CoIntel Prometheus. I don't have thoughts on them because that's beyond my capabilities. I'm just working on my own parser right now, which looks like this, which is currently broken because I have broken it horribly. It's supposed to be trying to parse itself, and that's because I've completely broken the expression logic right now. Yeah, sorry. I won't try to guess. I'll just tell you that I don't know. I'll be unlike AI. So if you asked AI like ChatGPT, if it didn't know, which it doesn't know anything, but ChatGPT is a great con artist. When it can't give you correct information, it pretends that it's very sure and it knows for sure that the answer is whatever it's hallucinating. But I'm not going to do that. Okay, from the top. We need to do check expression y, because we need to know what kind it is. And then once we figure out what it is, we assert that it is. So this needs to be expression 0. And then I'll do 1, 2, 3 later. So then to check, we're doing a look ahead with an alt, and we're looking for the longest first. This should do check expr 0. If it returned nil, then it's it couldn't parse it as an expression. Why don't we just say unable to parse expression? I don't need it to be like informative. I just need to say that it wasn't able to. So if it's not able to, it just give up. Otherwise, if it recognizes what kind it is, it'll try to parse them. Okay, then then the checks are all like layered. So check expression 5 is it sees can it get a 4 followed by an equals or not equals. If so, yes. Okay, then these are all sort of similar, right? 4 is try a 0 followed by a greater than, all that stuff. So then do I have a check 0? I don't. What am I doing? I should just copy check 4, right? For 0. So check for 0 is we're checking for a function call or a ref. And if so, it's a 0, it's a level 0 expression. Level 0 is oh, here these share a common first token, right? So I do need to do an alt. Well, this needs to be a check function call. Your parser is written in C. When you compile with all optimizations, all these recursive calls are removed and replaced with using the call stack. That's cool. So one thing about my programmable parser that's different is really there are two stages of compiling, so to speak. So I compile a compiler. Well, really, I'm compiling an interpreter. So this language is an interpreted language, and it's a two-stage interpreted language. So this is compiled into memory into an abstract syntax tree, which then the parser walks through along with the data. So it's trying to match, see how it's like matching nodes in the abstract syntax tree to blocks of bytes on the left. Kind of hard to describe, but you end up with two input files. One is the file we're looking at, and the other one is whatever you decided to throw into the parser, and it tries to match the two. So it uses this as a recipe on try to matching bytes of the input, and then when it does a match, it'll emit output nodes, which are these things on the right. So when it matched this name formats, it knows that it came from the ID format, and it has a certain value, which is extracted from the input. It's easier to show if I show you a real format like GIF, or do you say GIF, whichever you prefer. So here is example. So when I click on these individual rendering blocks, it actually is extracting the image and showing it down here. So I can basically show you that this is an animated GIF that is the Pog slide GIF, right? So the format input is this. So GIF has a header, logical screen. There's a loop with data and trailer. The loop ends up creating a vector of data blocks, but the ones that aren't in a loop there's singles of them. You see how like it matches elements from the format, like the screen width and height, right? It matched them to where it was in the input because the way it built this output data structure is it used the compiled format language into an abstract syntax tree and then walked it along with the input data in order, in bit order from the first to the last bit, and spat out a big tree whose nodes match what was in the recipe but are now matched to the input. Well, I would like to release it at one point. I can't really work on open source right now because of the job I have. So, but eventually, yeah, I hope to. Yeah, today is the meta challenge. It needs to be able to parse itself. This is one of the weird cases where the input file is actually the same thing that I'm using to parse itself right here. So we'll see the actual thing. The format description is also the input. Sir Elfman, you may or may not be correct. What's the answer I'm supposed to give? I can neither confirm nor deny. But yeah, some companies just don't want to have a conflict of interest. So when I stream, I have to stream things that are unrelated to my job, and because there's a lot of companies also don't want you to represent the company when you're being public, like I am sort of. Um, I have. It's like if we were at a party, I could tell you where I worked, but then if you started asking me questions about my work, I'd have to say, well, I can't really talk about work. So I can say that I work at a certain fruit company, but I really can't say what I work on, and anything I say does not represent the company, right? They don't want people coming to me saying, "Hey, could you, I have this bug? Could you fix it, or could you find the person to like I yeah." There's a whole division of the company for that. Like, and I'm not the right one to go to for that. And if I say something that reflects poorly, um, I don't. They don't want it to attach to them. So yeah, need to have that separation. Similar reasons, like all the compute devices that I have at home and the ones I use for work are separate. Keep work and home separate. All right, I got distracted. So to check if something is an expression zero, we're just seeing is it a function call or a reference, right? But when we know it's a expression zero, uh actually I think I do want to break this up here, and these need to be parsed differently, right? Let me think about that. So the problem is a reference and a function call start the same. They both start with an identifier. It's just that a function call has a parentheses in it. If we knew that it was a function call, yeah. If we knew that it was a function call, wait, wouldn't I just want to return it? Yeah. Don't I want this to bubble up? Oh, wait. I just noticed something. Yes. Okay, so these should just return themselves. Because internally yeah. So we want to basically return the most specific thing we can. Because check expression zero, then it allows me to have it return something specific here. Function call versus a ref. And then I guess, yeah, the default would be expression zero. So that when we get to hold on. Shoot. Let's work again. To run into any performance issues being immediate mode with all the text rendering? Yes. If I have a lot of nodes over here on the right, it gets really slow. But that's my own fault because there's a lot of tree searching, and I could probably optimize that by knowing which rows are visible and just skip everything else. And I could probably do a lot more caching. But as far as like the rendering and eGUI and all this, not really. Like this is all pretty smooth, even in a debug build. The trick is to cache the expensive things, like the building of this texture. I only build it once, and it's not in the immediate mode path. And I kind of wish eGUI was a little bit more strict about that. Like it'll let you do expensive things in the immediate mode loop that you should have cached or pre-computed. Um, they discourage that by having the widgets be stateless. So if your state is your texture, then it's like it discourages putting it in the immediate loop. So you end up having your state separate from the immediate loop's tree structure, right? Um, but it's not enforced. So you can make mistakes. Like I could be converting this image into a texture every single render loop, and that would be horribly expensive and would probably lag. And I'd be able to get away with it until I profiled it and saw, well, I'm reconstructing a new texture every single time I draw. I only need to do that once and then cache it. Um, those are the only times I really see lag is because I just have not optimized it myself, or if I do a mistake, like I should have cached something and I didn't. But yeah, otherwise, not really. I'm getting myself confused. Okay, I know what it is. So I need to introduce extra steps here. If it's a function call. Function call. If it's a ref, it's a ref. Okay. So then I don't need an expr 0. This return is not necessary. We're just gonna break out the expression zeros separately. Then that is not needed. Okay, let's see how this parses now. Oh, 226. By the way, do you see the bug? How Pepe is still sticking around even though we haven't parsed him in a long time? Because I forgot to clear that. Our brace expected. Oh, that goes there. That goes there. There. Okay. Okay, there's a function call left brace. Okay, so it didn't. I hosed the greater than. So it thought it was a function call, and it didn't try to see that it was a greater than. So let's see how that works. Check expression 5. This should be a, it was not a 5, so try a 4. 4 is a 0. Ah, I see. I do need a 0. Yeah. Well, yes, so I do need a 0. But only because if we don't know what it is, it's gonna be one of these, right? Function call or ref. Able to parse the expression. Okay, it's really confused. So wait. So then tries a 4, which 4 tries it as a 0, as with the token greater than. Function call. That should have worked. Oh, except for I need some get rid of some white space. No, already got rid of it there. Okay, then I don't know why it unable to parse expression. Okay, the check expression failed. Wait, it should have passed as a function call. Let's do a warning. Check expr 4. Okay, so it got to the token and it gave up. So, well, did it give up? Let me see. Okay, so it didn't parse the token. It didn't parse this greater than. Oh, I think I know why. So, no, function call does end up with optional parentheses. So, it's this expression that it's trying to parse, right? So ID, parentheses, end parentheses, and it should have gotten to that greater than and saw that it was a greater than. When in doubt, add print statements. Okay, so it failed to parse this. So let's look ahead, I guess. Well, hold on. Token. Token do. Have a greater than. So why isn't that working? Hey there, Avalanche Pointer. What's a programmable parser? So I'll just show this again. So given a configuration and a data file like pogslide, which is a animated GIF, it puts the animated GIF's raw contents here, and then it uses a format description, which looks like this, which is in my own custom language. It uses that to parse. So if you describe how to parse a GIF file, and you put an actual GIF file in, it will turn all of these bytes into this output, and I even have some GUI tools here where it will interpret the output as an image and show it down here. You guys can see that, right? It's not completely cut off. So yeah. Programmable means, like I said, like this custom language. So it's like, for example, a GIF starts with a header which has a string signature of 24 bits long, and it has to be GIF. So that's what this signature is. So if I changed it to be like it has to be JIX, now it's gonna say, oh, bad signature because GIF is not JIX, right? Put that back to GIF, and now it parses as a GIF again. Well, thanks, TS Joss. So by giving it different format files, you can teach it different formats. So here's the one from JSON. So JSON document has a value, which value can be an object. You know, all this stuff like an object is a brace, name value separated by commas, the close brace. A name value is just a name and a value again. is an object, all these different things it can be. So this language is sort of giving a recipe for the parser on how to parse the input file. So if it was a JSON format and you gave it a JSON file, it would match and show you the structure on the right. If it's a GIF format and you gave it a GIF file, it'll match it and output something. So the description has to match the actual thing, and when it does, it shows you one-to-one. Every input byte goes to something in the output, right? So I can click anywhere, and it's like, well, I'm still in the global color table. Let's click on something more interesting. So you'll see that it says Netscape 2.0. You'd be like, oh, what's that there? Well, that's part of an application extension. There's an application identifier called Netscape in there. If I click way down in the middle of the file somewhere, it's like, okay, we're in the 26th sub block of the 6th data block, which is a graphic rendering block, which displays that. So yeah, and you can do things like to recover the image. It had to take these data blocks that are composed of like sizes and blocks, bits. It puts them end to end, and then it decodes it as a LZW stream with the inputs mapped to different outputs. So each input is a code to the decoder, and then that can sometimes output pixels. So in this case, this image was 6,000 symbols long for the decoder. To get was it 11,000 something pixels? So a compression ratio of 2 to 1 roughly. Anyway, I can go on and on about that stuff. Right now we're doing the meta challenge where the parser should be able to parse its own language. That's what I'm working on. Although I'm getting kind of tired, I'm losing my voice, and it's almost 4 hours long, so I might not be able to get much further. I'm trying to figure out why it can't parse this as an expression level 4. It got the 0, which is the remaining. Oh, maybe that's the problem. Maybe it's not printing out what that is. So I should maybe print that out. So let's print that out. What's it gonna print now? Let's see. It's a nil. Have it out something. Return function call. Oh, interesting. Still says nil, so it's not parsing any of these. So we should have something in here. Error. Failed to parse as experf 0. Yep, so it is failing. It's failing to parse as a function. It should parse as a function call, so why is it not? Identifier, ren, optional expression list. Maybe it's in this expression list. Let's comment that out and see what I get. No, it's just completely broken now. Guess who's back? Escaping cat. Got out and we had to go chase her. Let it go. Oh, I broke my expression. A while, and then it can't parse that. I know, cat. Function call ID. So it sees that. It saw the parenthesis. See if it gets to the the right parentheses. It is. So why is that not working? Expression 0 is function call. Okay, it did see it. Hold on. Not seeing expression 4s anymore. Oh, wait. This should not be a nil. This needs to be an error. Ugh. What was I thinking? We can't return a nil there. The check has to fail. Error. Yes, it has to fail. Not an expression 5. Okay, we're getting further. I think I just need to tell this has to be a full-on error. Did it get further? Oh, it did. Cool. All right, so it figured out that while function call was the expression, and it's even getting into the statements. Okay, so I fixed it, sort of. I just need to clean out all my warnings now. So then, yeah. Do we still need to return something? I guess so. Yeah, so this has to also turn an error. Okay, and then I can put the expression list back in here. Okay, cool. So formats is parsed. Oh, what happened here? Get rid of this chatter here. Expression 0 is a function call. I don't need to see that anymore. Coding cat. Code. Coding cat does not feel like helping me code today. Right. Okay, it doesn't like returning. The return statement doesn't like express a reference. So, am I missing ref? I have ref. Check for 0, check ref. Oh, there's no check ref. That's what's missing? Yep, I don't have a check ref. Check ref. I think it's just ID right now. Cool. We have a return statement. Returns name. Semicolon. All right, good. Okay, we're building back up. I have unbroken it now. We have an ignore, we have a look ahead, and then it bombed on this one because, right, the function call has arguments. If statement, if function call Oh, it's the equality. It didn't match the equals equals. Okay, so that's an expression 5, right? I think I'm missing some white space stuff in here. Word. So what happens to the white space after a function call? I eat it there. Okay. Am I not eating the thing after the equal equal? Expression 5, expression 4. Ref. Yeah, so yeah, I'm just inconsistent about where I'm eating all the white space. I guess I could just sprinkle those liberally. So like, for example, I can put that, I have to be consistent about it too. Eat there and there and there. That did not help, so we're going to do the same thing for, well, that should have helped. Just checking. That shouldn't be an expression function call. It should be an expression. Oh, wait a minute. I know why. It's the string on the right-hand side that is not, it's not matching correctly. Right. So I need literal string is what I need. So that's another expression 0, right? So check literal. We'll just check string. And then if it is a string, right here, I need to parse it as a string. Okay, and then we have to add that down here. So literal UI. So check string is easy. We just look one character ahead and see if it's the double quote, right? So where did I do that? Like this thing. UTF-8, so return that it is equal to double quote. Okay, and then string, actually, with check, I don't need to do a look ahead because we're already doing a look ahead. So string is that we have the quote, well, token? Quote. And let me steal what I did for JSON. That one open. Okay, JSON string, right? This thing. I think I'm just going to do the same thing. So between the two quotes, we have string element. So string element, we'll just copy that as is. Okay. $275. Quote expected. Here, right? I broke it. The very first statement in the while loop. Oh, it expected a string there? What? Expert list. Check expression. If it's not nil. Okay, so check expression. Does it check expression 0? Check string, return string. So it thought an empty thing was a string. So check string. Wait, it shouldn't have been a quote. Oh, that's what we're gonna. Oh, I see. Yeah, this is supposed to be if return string. Or maybe I can just, if it parses as a string. Yeah, okay, so this just has to say if it's not a string. I say not a string. Not a string. Ooh! Going back to working again. It's still not matching that exactly. Let's see if it's getting into string. So, warning. Looks like a string. I want to make sure that's actually getting to that point. Bye, cat. The cat left. I didn't even notice. Okay, so it didn't even see that there was a string there. Probably because I need to remove the white space. After I know I have the white space removed. Oh wait. That's not right. Yeah, wait. So that should just be expr, right? Still broken. Ah. This is hard. Checking for string. Okay, it checked for a string 3 times. That's good, I guess. Okay. It's this that we're trying to match, right? So it's got to be function call equals a string. So check the expression. Try 5. 5 is there's a 4, which would be that it's a 0, which is one of them is a function call. So it'll succeed. Returning function call, which we don't care about, and then greater than, it'll fail, so it's not an expression 4. It'll back up, and it'll try a 4, which it'll fail. So it'll try a 0, Oh, wait, hold on. Is that why 4 needs to match? Oh, that's the problem. 4 has to have greater than. Okay. So, this, I'm going about this wrong. A 4 can be a 0. Yeah, I've been going about this wrong. This has to be an alt. All the different kinds of things that can go there, 4 or below, or I have to, or a 4 has to have a 0 in it. But the 4 is a 0 followed by something. Okay, then I need, this has to be actually all the way to the top then. Uh, check. Oh my goodness. Yeah, a 5 can just be a 4 without an operator. Okay, then this is all optional, right? I think the check is fine. It's just that this one, it has to, like a 5 needs, right. This part needs to be all optional. This has to be all optional. So I'm going to put this all in an alt. And the same thing for a 4. This is an alt. Only these are not alternatives. That's a sequence. So hold on. Yeah, so it should be like 5. Really, I need another syntax here. Like opt. It's like all of this or nothing. Right now, the closest I can do is I have an alt with the entire thing in it, like X for 5, part 2. Oh, it's gonna look crummy. And the same thing for 4. It's gonna look gross. Okay, it got to looks like a string, but it didn't actually parse it as a. So it just didn't parse it as a string? Hold on. See if it actually got that far. Yes, it did, and it failed. So why did it fail? Oh, I didn't initialize value. What happened to value? Ah, that got lost. Got lost in the copy. Oh. Value, right? Thing. But anyway, this is failing somehow. I mean, that worked. So wait, why did it not see the end quote? Okay. So why didn't it return it? Okay, it didn't see the end quote. Oh, because I had the same thing, but my errors are being suppressed, so I can't see them. But it's the same thing in JSON. I had to actually name it quote and end quote. I think I hit this before. Now I bet it'll work. Yes. Okay. So it saw that it's function call, and then part 2 is the equals that. It's this part 2 I don't like. Oh, I would like to collapse that if I can. Okay, so this is all done. We don't need these warnings anymore. Okay, so then okay, then we're off to the next format. Okay, so it doesn't like the litter. It didn't like. Okay, so we're on to the next thing that I don't have parsing yet. Get rid of that. Before I move on, I want to fix this clunkiness here. This part 2 clunkiness. So how do I really fix that? I think what I want to do is if we check if something is an expression 5, if we're parsing something as we shouldn't have to parse it as an expression 5. That's what it should be, right? So we're trying these in order. And when we're trying them, okay, it just doesn't know what the left-hand side is. It could be a 4 or less. So I think what I want to do is actually expression, I want an alt here, right? I went down that path, but it didn't work for some reason, right? What was it? Oh, that this isn't greedy enough. That's what it was. That's why. Okay, so no, that should be greedy enough. The 4 starts with the 0. Okay, then I should be able to get rid of the part 2 here. If that breaks, now let's investigate why. It broke on this one again. Okay, let me walk through this again. So, it's expecting an expression there, right? It found the word if, and then it's expecting an expression. So first it does check expression. Check expression is going to try a 5, which it is, right? It should be. So a 5 should be, it's either a 4 or a 0, and followed by an equals. So a 4 should fail before, because a 4 needs to have a greater than. So it should try again with 0, and it should succeed with function call, right? And so it should be, that should have worked. I don't see why it wouldn't work. It says greater than expected. Why is it greater than expected? Let's actually print it here. Parsing expr as check expr. Give me some more insight into it. As a reference. Oh, there's sub-expressions. The first one's level 4. Ref, what? Oh, I see. But it's not a 5, that's the problem. Expression 5, oh no, it is. Just the left-hand side is wrong. Not a 4. That's the problem. Oh, I see. I need to do the same thing that I did on the check. Right? Yeah. Okay. That's what did it. Okay. Well, what's this error though? Same one? Yeah, okay. That was what it was. So then I don't need that warning anymore. Yep. Okay. So many little things. How much longer do I want to go? I probably lost everybody who was watching, but that's okay. I need to get through this. Okay, really the whole point of the checks is it does minimal scanning ahead to see if it matches a certain thing. And then if it's convinced that it is, it goes back and actually parses it. And when it actually parses it, it's allowed to do an alt up to the point where it would have matched. That's this much. And then after, so it's this alt that we don't want because that has to match an expression on the right hand side. Right, so we're still good. Yes. So I shouldn't ever call expr 0, should I? Well, that's only for convenience. Yeah. Okay. But what if we get down to this else, what do I do? Oh, then it's that. Okay. So it has to, the check expression, it has to parse as something. Otherwise, we are going to say it's nothing. The only difference here is that this stops early before doing the right-hand side. Actually, and this can be greedy now, right? The I can actually have this match the grammar. This can try a 5, and then try a 4, and then try a 0, and then this can do the same thing. And this can be a 4 now instead of being escaping all the way to the top. Right, and this can be a 4 as well. And this can also be a expr 4. That should not break anything. I think I broke it. Stack Overflow. Woohoo! Gonna overflow every time I run it. Okay, so oh yeah, it can't recurse into itself like that. Yeah. This is wrong. It has to be a 0 at that point. I'm allowed to do it in the grammar, but I can't do it here because of because it's just gonna infinitely recurse. So yeah, I can't do that. Back to what I had before. So yeah, the consequence of that is that if you have like A equals B equals C, it's gonna do A down here. A equals well here I can do a 5. It's gonna associate in the wrong direction, but that's okay. Oh, and this I can put an expr 4 here, right? As long as literal UI is one of the things that an expr 0 can be. So let's put that in here. Check literal UI. I don't have a check literal UI. But that's right now pretty easy because it's got to start with a digit. Actually, can I just say digit? If it fails, then it's not a literal UI right now. Actually, then for check string, I can make that easy too. And I just try it as a, can I just do this? Let it error out if it's not. Yeah, that's what I'm doing for check function call. Okay, this just has to all the way go up to the top, so I have to have a case here. To fix this. I didn't fix it. Too big. Expert for failed to parse it as expressions. Oh, expression 0 doesn't have a literal in there. I don't think I'm returning the right thing there. Return? Turn. That's wrong. It's 4 or below. And a 4. Yeah. That's also wrong then. Isn't it? Yeah, this has to be an alt. Well, hold on. I was trying to not do an alt there because this it has to I'll do it. I'm gonna regret this. Yeah, 4 is gonna be a 4 or a 0. Okay. Just if there are any errors, it's gonna be hard to see them. Oh, and I have a Stack Overflow. Great. How could that cause a Stack Overflow? I don't see how that could happen. Return that, see if that's where it ran. Okay, so why would that cause a Stack Overflow? It'll try this path first, which means it has to parse as that, which it will do because it will match that. But then it won't match the greater than, so it should fall back and try 0, which should match that. Okay, I don't understand why. Wait. So that being like a 0. Okay, now I'm really... Oh, there's a collision, that's why. Oh, I see. I see the problem. Again, with this alt junk. This has to be left-hand side. This has to be named. Why is there a Stack Overflow, though? Okay. What if I just reduce that to right hands? Still a Stack Over. What? Is it this up here? Maybe. Okay, it is that. Ooh. Literal UI matched on nothing. That's a problem. Not supposed to match on nothing. It matched on 0 bits. Okay, so that's the problem. So literal UI is matching on 0 bits. Okay. Yeah, it has to have a digit. There has to be a first digit. So why did I copied this from JSON. What happened to JSON that I allowed that? Oh, because it used to have... Okay. Actually, this is a bug. You can it'll match an empty string against a number and say it's 0. Okay, I gotta remember that. So Nightshade Dude is not a mod. Is he a mod everywhere else? Did I fix that oversight? So investigate empty string matching number in JSON format. Okay. So in the meantime, let me fix it in mine. I think maybe you might be thinking about the cohort of streams that are associated with the Primogen. So like stream cohorts tend to have a lot of mods in common. So I don't really consider myself in the same cohort as the Primogen because I have a different focus for my stream. So the Primogen likes to entertain with coding as the context of the entertainment. But I like to work on my hobby. So my hobby is not to entertain. So I'm kind of, there's a weak association in that we're both coding, but I'm not an entertainer, and I hazard to say that the Primogen doesn't focus mainly on coding. It's mostly entertainment. But there is a little bit of coding for both, so we tend to have this similar viewer. Hey there, Tower Strike. Okay. Yeah, I need to require a digit to start with, right? So there's no first. Or actually, oh, maybe that's how I did it before here. I had to check to see if, that's what it is. That's what it was. So hold on. So this is done. It didn't actually match. I just wasn't seeing the if first clause at the bottom. Okay, vindicated. I was just missing this, so we need to have that here. Not literal UI. Although it's probably easier if I just I'll worry about that later. uh, what? Celebrate's expected on 496. I'm in the wrong one. What? Oh. It's hard when you're doing a meta challenge. I don't know if that error is actually in the fmt.fmt or if it's what it's parsing when it parses itself. Okay. So this is still wrong. So it's still wait. That's expression 5. What about the string? How did that actually pass? Expression 5's parsing. Oh, shoot. Yeah. So it didn't match either of those. I need to have an else. Unable to parse right hand side. Yeah, okay. So that's the actual problem. It couldn't parse the right hand side. Why couldn't it parse it? So I broke my string format again. So a 0. Oh, I don't have string in here. String, the actual format? Yes, it is. Oh, cool. So we got past that. All right. This is so hard. Yeah, so we're back to it doesn't know how to parse a literal array or vector. Okay. Have to teach it how to do that. Let me clean this up. So where's expression 0 used? Do we need to return anything here? Don't I want to show something better from this? Yeah, I don't think I want to actually return that. I think I actually want to return the literal. So not the string literally, I actually return it. This should return the string. Let's have ref. Actually, why don't we just make the thing return the right value? Okay, so then it should say, yeah, function call greater than 0, right? I don't think that the white space should be the job of literal UI though. So that shouldn't be there. It should really be the job of, we should get rid of we should ignore the white space around inside the expression, right? So like there and there and there. And on 0 also, well actually that should work. That should be fine, right? Yeah, so the 0 is just the 0. Greater than is just the greater than. Function call remaining parentheses. Okay, good. Expression list is parse, but there's no bits for it. I guess that's fine. So there's is an expression list, it just is empty. Okay, I just want to make sure that it's that I like the way it looks before I move on. So there's no arguments. The name is format. That's statement. There's a while loop. Okay, I'm fine with that. Next format. We have 6 statements. We have a parse statement. So this all the white spaces have been removed around that. That's good. Word return name, semicolon. Parse our brace has no name. Okay. This one, okay, good. All right, next format. 4 statements. Ignore or optional white space. Okay, good. Head. Oh, that's wrong. I shouldn't say ignore. Look ahead. This is look ahead. Look ahead. UTF-8 name that. Okay, good. Okay, so the white space is eaten in the wrong spot for if statement. So function call is including white space before it for some reason. It shouldn't. Unless ID is. It is. Okay, let's get rid of that. Okay. Yeah, see, when I remove it from one place, I need to put it where it should have been, which is in the while. Yeah, so white space around there. So yeah, that makes more sense. So the white space should be like between elements in higher order things, not before or after innermost things. So like, should probably do that. That's correct. Yeah, okay, and then yeah. Well, hold on. Check statement. That'll remove the white space before each one. So that should work. Okay. Oh my god. Do that, right? Same thing here. Yeah, I'll just try to follow the rule that I eat white space between any 2 things at the highest level. So if any construct builds off of 2 or more lower ones, then I have, and that white space is allowed between them, then I eat the white space there. So there, there, and there. There. Looking good. So there. So I think that might be a little pedantic because expressionless, I think, eats white space trying to look for the next thing anyway. Okay, cool. So we're getting down to the same place, right? Yeah. So I guess if I'm happy enough with this, I'll move on to the next thing to teach it. Oh, well, hold on. Before this gets way out of hand, I should sort these. So they should be sorted from like the highest level to the lowest level. The white space being at the lowest level, and then oh yeah, I was gonna combine word and token, right? I think these two are basically equivalent. Um, and I think I'm just gonna get rid of token, and then wherever I'm using token, I'm gonna get rid of token, and then I'm gonna turn word into token, and then everywhere, everything that references a word, I'll turn into token. And then I'll give it a name, an optional name. So word will have an optional name, and then we'll say if, well, label equals name. If label is nil, label equals expected. And then this is label. Okay, and then I'm gonna get rid of token. And then wherever there is word becomes token. So word, select all matches. They're not, okay, so word just becomes token everywhere. Token. I don't think I need to have GT. I think that the greater than token is self-explanatory. In fact, I think the semi is also maybe I don't need the name at all. Yeah, you know, I think I'm just going to remove the name. I don't think we need it. So, find all these spots here. Then to the end of the line, go back and hit save. Okay. No more name. It's just expected. Right. I probably horribly broke this, didn't I? Yes, I did. Extra arguments a token on 369. Oh, yep, here. So yeah, I guess my language doesn't like extra arguments. 309. I had these helpers. Should I have one for quote? I think I should. And then, or have quote. So, whoa, token quote should just be quote. Okay. Okay. I broke it. I broke it. While loop. Statement here. Oh. Didn't think the state. Okay, so I need to eat some more white space, I guess. While loop. Where are you? Here we are. It's in statements actually, right? So state. Where are you? Statements. Well, wait a minute. Shouldn't it have looped back around? It's the while. Look, right, the statements it parsed. Actually, that's not even correct, is it? Um, it should have shown me all of the. Oh, wait a minute. No. Yeah, it ended too early. Statement. I have removing white space there, so why is it not removing the white space? Why is it expecting an R brace there? It's not parse. Oh, it's not parsing the ignore correctly. All right. um, yeah, I think that's what it is, right? Ah, what did I break? Let's see. Warning. Should get to that line. Is not. It didn't even get in there. So, what does that tell me? Um, check statement is failing? I'm just seeing printf style error analysis. So, okay, so saw the while twice. It's just doing a lot of speculative checking for things. Okay, here's where it should have seen the minus and it didn't. So why didn't it? Let's do a warning. In addition to the error, we'll do a warning. The best way to see it, actually. Okay, and then scrolling down. Oh, we should see what it actual. See. Okay, so it did see the minus. So parsing. Wait, parse token minus and no result? What's this check alpha num? Oh, right. Okay, that was to distinguish between like for versus format. So it would see the for and say, well, let me see if there's an alphanumeric after it, then it's not a for, right? If it finds a substring of a longer string, the problem is I think that it's getting to that plus. It's seeing this minus, that's a token, but then it says the O and it thinks it's part of a longer token. So then I think I need to distinguish between symbols and tokens. I guess the easiest way would be if the first character is alphanumeric. Yeah. If the first only do this if the first character is alphanumeric. So if expected 0 equals greater than or well is alpha. Whoops. Whatever hotkey I'm hitting for that is not what I should be. And I should leave myself a comment here. Detect cases where a longer token the beginning of a longer token. Well, again, I did hit that key I shouldn't hit. Detect cases where the beginning of a longer token matches what we're looking for. Okay. It's actually going to match minus. Like another problem is if I have minus versus minus minus, right? It's going to see if you're looking at minus minus, it's going to see the minus. So shoot. Well, I could think of a hack, which is where we have an else. And then if we, which means that we would always do this check. And then we would negate this. But only if this is not white space. Okay, how do I detect white space thing? Is white space. How do I say this? Is white space? White space? Make it a function. Okay, and then because I want to reuse it here, we're gonna F8 pair next. If is white space next. If it's not white space, then check it for an alphanumeric. Either if the token that we're expecting is alphanumeric, and if the next character is alphanumeric, then it's a longer alphanumeric, and we want to do an error. So if it's not alphanumeric, then the next character has to be either whitespace or alphanumeric. Otherwise, it's a longer non-alphanumeric token. I think that'll work. Did not work, so let's see. Okay, it didn't see a function call again. So we're regressing even further. It parsed the token, parentheses, but it didn't say parsed. Why not? Oh, because, oh, shoot. The next one is also non-alphanumeric. Okay, so I hosed my own check here. Shoot. So it's more complicated than I thought it would be. So I can't do this one. To do what about minus versus minus minus? I mean, one alternative is like we actually have the set of all valid tokens. So we do what maybe we do what the Lexer does, and we turn our input into tokens first instead of processing as UTF-8 characters. So that actually might make more sense. That makes sense because I might actually want to see the input as a token sequence and then parsed. So it would actually parse like it actually. It would parse like it actually does internally. But that's more work. Shoot. Yeah, how are we going to tell the difference between a decrement call and an ignore? Well, I guess what we'll do is we'll scan for the longer token first. That's what that's what we're going to have to do. For now, make sure to scan for the longer tokens first. Yeah. So, still broken here. Why? Still not seeing. Still not matching the open parentheses. It should have fallen out of that. Didn't. Is alpha num num. Return. Oh, I don't have an is alpha num. That would explain it. I don't have an is alpha num. Okay, so is num. And it is this right here. Okay, that's weird. That changed something, but it didn't actually work. This is parsing token parentheses, and it didn't actually print anything. So that means it must have errored out here. So I'll probably see that if I do this. Oh, it's all longer token. Token as prefix. So we'll probably see. No, we're not seeing that. Okay, so it's something else. It's some other error here. Oh wait, I think I might have made a mistake up here in is alpha. No, that's got a semicolon. Oh, this has got the code. It's got to do a code thing around it. Shoot, that's what it is. A char around it. Think? No? Yes, that's what it was. Okay. God, my goodness. Okay. So problem is that this is actually not returning a. So indexing a string is not returning a character. It's returning a number. I need to put that on my to-do list. Don't need an untitled. Investigate a y len string returns a number instead of a char string. I'll get back to that later. Right now, I'll just turn it into a character manually. So then we're getting rid of all the warnings. Okay, so we're back failing in format 3 for the not knowing what to parse on the right hand side of that, right? Oh, actually, the whole thing is that it doesn't know what the assignment means. So we need to like be scanning ahead for an assignment. That's a kind of statement. So that's a statement where it's a reference equals. We have to scan ahead for reference equals something. Or reference equal. So where's the scan ahead for checkout? Here it is. So it has to go before here, right? So it would be like where's check state? How's check statement used again? Okay, so this is a problem because the first token doesn't tell us enough about the statement. What if I change this to statement type? And then statement can like Yeah. Shoot. I'll just have a check assignment first. It's not first anymore, it's type or statement type. Okay, so then we need a check assignment. So let's put it near where I'm going to put that kind of a statement. So like maybe near a return statement? So we would, this is an alt, so we're going to actually we're going to expect to be able to parse a ref, ignore some white space, and then we're going to expect the token assign equal. That should, it doesn't, if there's an equals equals, we'll think it's an assignment, but that's okay. I don't really care about parsing broken formats. I really only care about parsing correct formats. So if we get that fire, we return assignment. So then if we get assignment, I just want to see, it should at least print to do assignment. Okay, cool. To do assignment. Great. So then let's actually implement that assignment. So I loop if parse ignore look ahead return check assignment. Okay, so then it's all of this, and then we have the right hand side. So this is left hand side, and expression right hand side, and semicolon. Okay, did it get past that? Did not parse the right hand side. Okay, so good. It knows it's an assignment, and it got the reference and the fact that there's an assign there, but it doesn't understand the brackets. So that would be a type of expression, which is a literal array. I think that's all the way down at level 0. Yeah, so we have L bracket, right bracket, expression list is vector. So I just need to add that for expression 0. Expression 0. And the check expression 0, right? So should try to keep these in the same order so it's above a function call. So check literal vector. Sure. So then right here. So that's really easy. We just look for a token. Just like I do in check string, right? Doesn't check string. Yeah, it just looks for a quote. We're just going to look for a left bracket. And while we're at it, let's define left bracket and right bracket as tokens. So that's bracket. And that. Okay, and then we have to come in here and put it in the right spot. So if it is an assign, if it's a vector, then we need to parse it as a vector. Right? We could be parsing it as an general expression 0, and so there, I guess I want to put it in the same spot, so vector. All right, and then we actually need to define vector. So where's my check vector? Or a literal vector? I said vector and I meant literal vector. I should be consistent, shouldn't I? I think I had literal because I couldn't do UI. So instead of saying literal vector, let's just say check vector. Or let's just replace literal vector with vector. Okay, and then so vector goes here. So that's L bracket R bracket expression list with optional white space in between. Return the expression list. It still doesn't understand it. Unable to parse it as an expression. Okay, so it tried expr. Blah, 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 blah. Okay. Should go to check expression. Should have gone to check expression 0. It should have done a check vector. It should have saw an L bracket. Let's do a warning here. Found a vector. Okay, so it never found it. That's lightning. Put the cursor nearby so that we get back to it. Check vector never found. Well, hold on. Let's see if it's searching for a vector. Oh, hold on. I might have gotten that wrong again. Tokens that. It should be okay that it's followed by another bracket. That's fine. Never even saw it. Okay, on the assignment, I can put a little check, right? Oh, that's the problem. There's no white space there or there. Yep, I think that was it. Hey, got our vector, which is empty. Okay, good. So it understands assignments now. Then there's a look ahead, and then loops. It doesn't know how to do a loop. Although that's not a loop, it's an if statement. So, okay, it knew it was an if statement. If check alpha brace. Okay, so it's stuck on that loop. We need to teach it loop. Loop is easy. Let me get rid of my other warning. So let's teach it loops. Loop statement. We can't use the word loop while. Yeah. This is easy. Just like a while, only simpler. It's the token loop. No expression, just an brace statements. That's it. Okay, cool. So it got into the oh, still getting stuck. A loop statement. Okay, it's in the loop statement, and the first, okay, we're digging deep here, so I gotta scroll quite a bit here. Got the first parse statement. Okay, it doesn't know the assignment statement. Okay. One thing after another, right? It doesn't know, it just said, okay, it didn't recognize that it should be an assignment statement. Oh, that's not an assignment, that's an accumulation statement. Shoot, okay. So, accumulate. The special case of assignment. So we detect it similar way. So accumulate. So there's a reference. Let's make sure I get this right. Accumulate. Should be here somewhere. Not flip minus. Oh, it's statement, not expression. Simple statement, right? It's the same as assignment, only there's okay an optional number of bits. I forgot about that. Bits. Colon and expression. Oh, that's right. That's for when you're making synthetic bit streams and you want to add some bits. You have to say how many bits. Okay, so that's a little bit interesting. So it'll look basically, but it looks like an assignment only with an accumulate instead of an assign thing, and then an optional bits. So it'll be accumulate, which is plus equal, and then optional white space because we might have opt bits. Op bits. So if the next thing is a colon, okay, so rather than writing it from scratch, let me look for where I've done this before. I think it's like this. So we'll just copy this guy. Actually, it's actually kind of like the op ID, right? So op bits. So looks like we're eating the whites. So we don't really need to do that. If it's a colon, then it's a token colon. Oh, I was going to just do that colon, then it takes any expression there. So exper. The bits is a reserved word, right? So I need to num bits. Return num bits. Okay, where I copied that from had some extra stuff we don't need. This white space here, right? Op arguments already has the white space around it, so I don't need it at the beginning and end. Yep. Op bits. Okay. Yeah, so we look at one character, and if it's a colon, we expect a colon, and then maybe some white space, and then an expression, that's the number of bits. Okay. Then I need to add colon as a token. All right. We get further. it thinks that that's a parse statement. Okay, so it didn't look ahead and far enough to see that it's an accumulate. Okay. So it's probably in the check statement. Oh yeah, we don't have a check accumulate. Okay, see if that worked. Okay, it's an accumulate statement now. But it doesn't like a sign. Equals expected. Wait, what? Oh, yeah, because it's wrong here. Okay, accumulate statement is done. And then there's an ignore, and then a look ahead, and then had problem with this if statement. If one of the statements in there. Wow, this is deep. Okay. Oh, it's the break statement. It didn't like the break statement. To do break. Okay, break is easy. In fact, while I'm at it, I can do break, error, and warning all together, right? Okay. Near return statement. Okay, so it was break, error, warning, right? Break. I think that just is break, and that's the only thing you can have. There's no expression, and then error, the error token, and then there's an expression, and then there's the warning statement is warning with an expression. Okay, how far are we getting now? All the way down into here. Okay, that's the argument to a parse statement. Yeah, I don't have the optional argument list. Okay. It's after the ID, we have actually we have a whole bunch of things we're not supporting. So yeah, uh, one of the things is the expression list. Op expression list, I guess use the same thing. So it's after the optional ID. Args, yes, is that what I call it there anyway? Args, yes. And then there's bounds also, optional bounds. I already have an op bounds, right? No, I don't, but I have bits. Accumulate. I don't know what I just did. Hopefully I didn't tell it to end things. It is a bits. What's different between op bits and op bounds? Oh, it's more expressive. Okay, so bounds and bits are slightly very similar, but bounds is more expressive. I'll do the bounds later. So don't have op expression list, so let's add it. Okay, where to add it? I have expression list, right? Add it there. So if I'm right, op expression list is, yeah, it's either empty or it's a left parentheses than an expression list. So it's kind of like the op args thing. So look ahead, if it's a parentheses, lparen, and then it's expr list. Expr list. Okay, now how far did you get? Okay, so it didn't understand the else if after an if. All right. Well, I'm making a lot of progress, but I'm getting kind of tired. I think I just have to keep going and fill in all of the things that are missing here, all the things that are marked to do. So maybe that's the. I'll wrap up this train by marking all the things that are to do. I already know that in the parse statement, I'm missing something, right? So here, there's like to do op bounds, and there's also I added another thing there. Script and then op script and or span statements. Right. Oh, and bounds and span statement is also permitted on ignores and look along with the expression list. I can add that now, right? Yes, I can add. I can just take all of this and just add it to ignores. So that would go on top of there. Put that there. Okay, and then it's just span statement. Thens aren't allowed for ignores. So this much goes copy and paste there. All right, and then what else have I not done yet? A bunch of different statement types. Those are all marked with error to dos, right? I haven't done bounded statements, haven't done inner parses. Alternatives for, oh, right, if statement is incomplete, right? If statement. So, where's if statement? So, to do alternatives. Else if, else. Okay. Oh, a bunch of expression stuff is missing too. So, yeah. We need, guess I'll mark it right here. To do expr 11 through 6, expr 3 to 1. And let me mark all the places where that's appropriate. So here as well. This is just this part. Here we have to do 3 to 1. And here too, I think. Yep. And then, right, there's a bunch of zeros that are missing. I'll just say lots missing here. Lots of things missing here. And matching here. Okay, and then okay. That covers like literal sets and maps and stuff like that. What else? The top. Oh, the expression 5 and 4. I had not equal, but I don't have for 4, I don't have the other 3. Actually, maybe I could just throw that in here. So like expression 5 had an alt with different tokens, and 4 the check also needs that, right? So both of the check and then the real thing, I have that. You know, the beginning part is actually exactly the same in the real thing, so kind of think that I should combine them, but yeah. This really should have an else, right? We can't allow there to be missing. And same thing in 4. Well, 4, it's not an all. Okay, so yeah, that was the thing I was going to do here, right? So, right, here we'd have alternate tokens we allow. So less than equal, greater than equal, less than and equal, and greater than. So I'm going to copy the same thing over to here. And these are called, I wanted to call them op, right? And then should I just call them up here? I don't really need to, but I kind of want to. Okay, so I just threw them in there that 4 has, let's see if I broke anything. It did. Up unexpected on 312. Oh, that's right, because that's not where you put them. Put them here. Okay, I think fix this here too. There. All right, as long as it's broken at the same spot, right? Where this else if. It doesn't know how to interpret the else if. It thinks it's a format. Okay. As long as I have all the to-dos marked on all the missing things, then I'm happy. So yeah. Oh, references. There are other kinds of references to do ref. So you can have dot and then another part, and the parts can chain. The parts can have indexing. So to do parts ref path with indexing, optional indexing. Okay, right? This already handles the escaping. I think that's how I escape strings all the time. Oh, this is not complete though, is it? Yeah. So, look, mark it to do. escape codes, escape sequences probably don't all match. Okay, so literal, oh yeah, this is strictly not handling all, yeah, so not strictly correct. Not properly handling binary, octal, hexadecimal. And that should show up here for this pattern up here. So we support binary, octal, decimal, and hexadecimal. And yeah, decimal isn't even correct because we're not supposed to. We're supposed to require. Oh, actually, it says digits 0 through 9, right? Yes, 0 through 9. So I think this hinges on the fact that if you start with a 0, it'll match octal first. Actually might have a bug here where if you do like a 0, 8, it actually interprets it as decimal, but a 0, 7 is an octal. But that's another story for another day. But I do need to handle hex and at least need to handle hex. But yeah, we're also missing expert 0 should say we're missing a bunch of stuff, right? Because we're also missing like literal decimals. What else? I think that's it. A lot of stuff in the different expression levels that we have to do. Okay. This isn't broken. We're parsing all the way down to... First thing we have a problem with is the else if, because we're not handling that yet. Close that. Going to send out of the virtual machine to back things up so I don't lose it. I'll lose all that work. And I'll just continue later. Sure when the next stream would be. If I'm feeling well, then probably tomorrow or Monday. Oh, hey there, 715209. When did you chat? A while ago and I didn't notice? I just kind of got super focused on what I was doing. But yeah, it's been almost 6 hours, and so I'm kind of out of steam here. I think we'll, since looks like he's streaming, I think we'll raid Chris. Oh, he's 2.5 hours in? Perfect. All right, we're going to go and hang out in Chris's stream. So thank you for watching. I hope that it wasn't too esoteric. And if it was, well, maybe you like that sort of thing. Anyway, I'll see you guys next time. Bye.